All right, thank you for coming this morning. I'm sure that we'll have more people flowing in over the course of today. I was looking around, I think maybe the two of you are the only new ones, so I don't know that we need a full introduction this morning. We did this yesterday, but generally this is an opportunity for us to introduce the students. We're running a studio this semester, and it's been sponsored through a grant with Gensler that's really looking at collaborative and multidisciplinary. Yes, we're in a very open space. We need to talk about. We do have a microphone if anyone needs it, or you can project. So Gensler approached us with this idea. We're looking at exposing students to teamwork and collaboration within the studio through conversations of a number of us at the college. We wanted to look at mass timber, which seems to be a lot of students' go-to solution for a lot of things these days. Sprinkle some mass timber on that, and it'll solve all the problems. More importantly, I think the discussion was around the fact that mass timber gives us an opportunity to talk about things from many different perspectives, from an engineering perspective, from a development perspective, from a forestry perspective, from natural resources, all of these types of different perspectives to bring things together. So the opportunities to bring a number of experts into the conversation today as a way to jumpstart the studio. We included students in the presentations as well, so that the students are sharing their work, and it starts to open that dialogue. Everyone knows what we're doing in the space, thanking our sponsors for all the support to make this happen from Up with Design. And then just look at the schedule. We've been doing a lot of programming in this space, our lecture series, this symposium, other panel discussions around the future of construction. We're here because of the conversations that started with Bedrock. Now that Matt's here, Ryan's probably coming this afternoon, coming later. Conversation around the future of construction. How does AI, how does robotics, digital fabrication, advances in computing, how does that potentially advance the future of construction? So we're running a lot of different programming around that topic. And so today we had two sessions yesterday where we were able to mix in student discussions or student presentations with experts and then have some panel discussions around that. So the lineup today is we've got the student group talking about their residential research, what's going to happen, actually I think this afternoon. The students will get their site after lunch. Over lunch. Jake and his work with Bedrock. Bedrock is giving us 5 potential sites to look at within the studio. So there are 5 student teams. Each student team is going to get a site, and you'll get that as an introduction over lunch today. So we've got Sandra, Jake, and Alexis presenting this morning as well. We'll do introductions for all of them as that happens. And I think that's a kind of brief setup for what we're looking at today. So I'll turn it over to the student group. And we're ahead of schedule.
So hi, my name is Ian Yanis. Hi, my name is Ian Yanis. This is Jason Wagner.
The third time is going to be amazing.
Good. All right. All right. I'm Ian Yanis. This is Jason Wagner, Marshall Meyer. We are architecture majors, and then this is Abby Zambek, and she is an interior design major. So first of all, we have to ask, what is mass timber? So when looking into mass timber, we have 4 major types, which is CLT cross-laminated timber, nail laminated timber, dowel laminated timber, and glue laminated timber, with CLT and glue lam being the main types used within structural systems such as flooring, walls, columns, girders, and other types of structural materials within a building.
Okay, so going into some brief history, In the late 1900s, mass timber began, and the first CLT plant was located in France, continuing into Switzerland, Germany, Austria, and into Europe. And this caused the spread of mass timber structures into the United States in the early 2000s, with the first building constructed in 2016 and the first multifamily high rise in 2018, and now leading Milwaukee, Wisconsin with the world's tallest mass timber structure, which contributes to the 1,900 completed projects in the United States.
Moving on to species selection, there are four main popular species for mass timber. There's pine, spruce, Douglas fir, and cedar. There's also other options as well. Douglas fir is the most popular species of softwood due to the mass timber having high strength and durability and cost. It's natively grown in the northwest region of the United States near Portland and Oregon and Washington. For pine, it is also one of the most commonly used species due to its lightweight nature and high affordability. It's native to more of the northeast section and parts of eastern Canada. Spruce is also native to the same area and has a high growth rate, with only being beaten by eastern white pine, according to Michigan State. And finally, we have cedar, which is native to parts in the Midwest, East Coast, and southeastern parts of the United States. And one of the main factors of it is that it's significantly harder than Douglas fir, which makes it less susceptible to dents. Moving into code requirements, the IBC code updated the construction types of tall mass timber buildings, which included 3 new construction types, 4A, 4B, and 4C. This allows them to go to differential heights of like 18 stories and however. Most states have already begun to adopt these changes with the update of the 2021 IBC code, but some states like Michigan have taken longer with changes to the 2024 IBC coming into effect soon.
When it comes to mass timber, one of the main concerns was always how does it deal with fire? Wood naturally is resistant to fire when it chars on the exterior, and when it comes to fire code, char is a main thing and how deep that char goes to protect the internal structure of the mass timber. And mass timber overall can actually withstand around 980 degrees Celsius when it is a CLT 5-ply system. And in Canada, the Wood Council there did an experiment that lasted a total of 19 hours of burning a wood structure and came to the conclusion that a CLT framed system could last around 2 hours with a 2-hour fire rating and with little impact on the stairwells and shafts.
For some of the recent changes in Michigan, they have been slow with us still operating under the 2015 Michigan Code. But as I said before, the 2024 IBC code is coming out soon with developments by Michigan State, Michigan Tech, research into hardwood and softwood application into the mass timber, leading the way of development for use in Michigan.
And then we go into spacing and grid systems. Typically in the U.S., most mass timber buildings are built by 20 by 20 to 30 by 30 grid systems, whereas we should really be considering a bit more of the rectangular systems of 12 by 20 to 20 by 32, because mainly in the square grids, there's intermediary beams, which MEP has to either route through or route around, whereas using a rectangular system does not have those intermediary beams. And then on the top, there's a chart with the panels and example floor spans. And then we're going into MEP integration, just like I talked about. So then we start off with floor integration, where there's hanging exposed, where you have to think a little bit more about runs and components. Raised modular floor system, which is really great for MEP, and you don't have to try and route anything and make it look as nice, and it's very easy to access and adds acoustical advantages. Gapped panels are a little bit more interesting, where you can have alternating panels covering different components, and then those are covered over by a subfloor. And then for lastly, concrete topping layer, where all of the components and conduits are placed in concrete casings over floors. And then for wall integration, there's 4 types of here as well. There's routed paneling, where either CNC can carve it out at the factory or on site. There's also exposed face application, much like the floor system, and then wainscoting panels and full additional stud walls, which those are both great because they allow you to have more acoustical advantages, which I'm going to talk about in my next slide. So by themselves, mass timber panels are not SCC rated that the IBC wants. IBC wants 50 minimum, 45 if field tested, and right now with even a 7-ply, it only reaches 44. So you need some additional massing to the assembly, and by increasing the SCC range, you either add mass and noise barriers and decouplers. And right here is one of those examples of the decouplers. It's completely structural, and it's just sort of like a spacer that goes in between and helps detract some of those parts from joining together and creating more vibrations.
Okay, so biophilic design, mass timber interiors are biophilic by nature and are strongly linked to well-being. Effects of wood and plants in interior space is shown to reduce stress and also increase productivity. And without these elements, it is said to be that individuals are 30% less satisfied. So interior design, mass timber construction is ideal for residential design because of its durability, flexibility, and sustainable properties. 5 to 10% of individuals making significant changes to their home each year. With these prefabricated mass timber panels allows for easy changes without affecting the overall structure. Some key design elements enhancing functionality and aesthetics is that the natural light in the floor to ceiling windows plays a crucial role in this. Natural timber elements creating that warmth and texture throughout the spaces. The grid pattern implementing helps with the acoustics throughout, and the flexible layouts allow for easy reconfiguration for diverse users and promoting adaptability.
Now we're going on to delivery methods for the mass timber because this is very important to how you're building your project. There's two main methods of getting this with three subsets of those. It's either by truck or by rail car. And then those three subsets are sequence delivery, one time, and phase. Sequence is where you're getting piece by piece as your project goes along. So say you're going onto this next portion, you can just contact the manufacturer and they will ship it to you. The next portion is one-time delivery, where all of it's shipped in a lump sum to the site, and then phase delivery, where if you're doing a specific portion of the building and you don't know how fast you're going to go, you might want all of your pieces there at once. These will all require different subsets of storage on site, but that's a good overview that can help you guys understand.
Moving on to manufacturers and suppliers. On this map, you can see a grouping of popular manufacturers around the country and in parts of the Canada. You can see that it lines up popularly with where softwoods are regionally grown and native. This usually means that they specialize in the species closest to their region, which factors into which one you want to select for your supply for your project. Other factors include the proximity to your site due to delivery costs, as mentioned before, but also the building type they specialize in, whether it be residential, commercial, or whatever. Also, other factors like environmental effects and the cost of the product. In our case, we found Nordic Structures to be our primary manufacturer because of the proximity to Southwest Michigan and their work on residential, along with Element 5 as their secondary supplier, who had work on affordable housing projects and is also located closely. We also have Timberline Group as our specialist group, as they specialize in custom housing projects. Moving into some of the primary Nordic systems they use, they specialize in Nordic XLAM, which is what they call cross-laminated timber, which they use mainly for floors, roofing, anything that has to do with panels. And then they specialize in using glue-lam beams and columns and decking for use. They also have plenty of typical details of connection types on their website, allowing for easier prefabrication and coordination with other disciplines.
So then going into the environmental effects of mass timber naturally has absorbing properties of CO2 emissions, and experts believe that by the year 2034, there will be around 24,000 mass timber constructions per year, which can actually lead to a over -40 net reduction of carbon emissions. And with mass timber, naturally over its life can hold those carbon emissions and is sustainably uh, healthy when it comes to using materials within construction.
Okay, so mass timber not only stores carbon, but it also reduces atmospheric CO2. And to put this into perspective, an 18-story mass timber structure is equivalent to taking 2,400 cars off the road annually. Mass timber, residential mass timber buildings average 50 to 100 years of life, and they can also return to the ecosystem at the end of its life cycle, unlike steel and concrete. And examples of this would be recycling into biofuel, reprocessing into new structures, or downcycling into furniture products or further design elements, minimizing waste.
Mass timber is also very much sustainable when it comes to the overall process of production as well as delivery, with it being mainly in system type. So you have small panels, flooring that's easily able to be taken to construction sites and then easily assembled, as well as disassembled and used in other projects, with then also it being easy to then ground down into mulch and then decomposed and used for future trees that can be planted and grown into mass timber. And then also mass timber is done well at influencing the competition of concrete and steel by forcing concrete to become more sustainable, or try to be, with utilizing the fly ash, which is from coal waste, that's being then added into the concrete. And then with steel, they use a lot more biocarbons that are incorporated within it, as well as using more sustainable resources for their material and production, which then decreases the amount of carbon emissions that are produced. But overall, mass timber still uses far less emissions when it comes to its production and overall lifespan of what it has, of how it impacts the environment. And then finally, going on to our precedent studies, I looked into the Ascent building in Milwaukee, Wisconsin, which is now currently the tallest mass timber building in the world, which overtook Vol Architects building in Norway. And this building itself uses two types of grid systems, one on the upper level of the structure, with then a singular grid system being used throughout the rest of the structure. The structure itself sits on a six-story kind of podium of concrete and stories there, with then 18 stories of mass timber framing on top. This system itself uses a GLT and CLT system to create these grid systems, and then some of the highlights of the structure itself are that, again, it is the tallest structure in the world, setting a precedent, and was able to work with local fire marshals and fire experts to create the first 3-hour fire-rated CLT panel. And then going on, the building itself can hold 7,200 tons of carbon, which is equal to 2,400 cars on the road worth of carbon emissions. And also the glue lam structure allows it to get to the height that it is. And then finally, when it comes to biophilic design and the interiors and the mental health of people, it exposes 50% of its interior mass structure, which then helps in influencing people's mental health and making them feel more comfortable in the residential space, especially since this is a place that they spend most of their life within. And then my secondary precedent is the Adohi Residence Hall in Fayetteville, Arkansas, which is a residence hall for the University of Arkansas. And this again uses two different styles of hybridization of its construction, with a main grid system composing of event space, which has concrete, steel, and wood. And then going into this one, it was able to win a LEED Silver Award for sustainability, which has actually set a precedent for most residential buildings now within university construction, as well as sets an example for student studies and making them feel comfortable in their environment.
Moving on to the building I studied, the Kaiser Brasserie Hall is located on Western Washington University's campus, and it is main use is for the workspace of computer engineering and electrical engineering students. It exemplifies the possibilities of environmental benefits from mass timber projects, as it is a self-sustaining, carbon-neutral building that was designed in the hopes to exceed LEED expectations and uses a photovoltaic paneling system and its own storage system to create a self-sustaining, energy-wise building. Uh, for the 1510 Webster building, it's located in Oakland, California, and is the tallest mass timber building on the West Coast, being a residential high-rise Type 4A building. The building's construction uses a foundational step reused from the previous building's foundation system to connect to 16 stories of mass timber apartments, which hold 222 rental units and 53 one-bedroom and 169 two-bedroom apartments. The interior is covered with veneer-based materials to create a more biophilic-friendly environment for the residents. And the project also shows off the mass timber construction benefits, as it saved reported 15% reduction on construction costs, as well as a 25% construction speed cost.
I'll run through this quickly since we're low on time. This is Thrive Apartments in Denver, Colorado. Want to go next? It's also a hybrid where it's got a concrete podium of 2 floors, and then it also has a main, you can go to the next one, grid system that's pretty standard throughout for the top 5 floors. And then Intro Apartments in Cleveland, Ohio, which is still one of the largest mass timber buildings in the world, or at least in the US. You can go next. It also uses a hybrid construction where it has very tall, almost double height ceilings at the base, and then mass timber throughout. Go next. And then 2 different floor types, grid systems. One where it has an inverted truss almost on the bottom, and the other that's a standard space. These are only possible. You could do these with steel, but you won't get the biophilic accents that you do get with mass timber. So having these in residential spaces and group spaces are equally as important, just as saving money for concrete and steel. Thank you.
Do we get to ask some questions?
Sure.
I'm just putting on that. I have so many questions. Good job. Also, you made my whole presentation so much shorter. So I have a question about species for mass timber. You mentioned cedar. Do you have a citation for the use of cedar in mass timber materials? I'm not aware of any cedar mass timber products that have been certified with PRG 320.
I kind of did basic research into that, as our main use is spruce for our primary use, especially with Nordic using like 90% black spruce. So it's kind of just basic research. I didn't really go very specific into it.
That was very elegant. Is it done? I don't think it's been certified yet. And then I have not a question, but a comment just about talking about the next life value proposition of mass timber. There's a lot of things that need to happen before mass timber can reliably move into next lives. The adhesives that are currently used in mass timber, are a significant barrier. They're a significant barrier because they're fossil fuel based, so it's very difficult for them to break down into materials that you might want to use for walls or something like that, or a lot of other things. And then because the mass timber materials are so customized, we're going to need a lot of standardization to make them be able to break down and move into new buildings, for example. Like, we just need to be kind of conscious about how we're talking about that to make sure that everybody knows, like, holy crap, we have so much work to do before this is a reality, but a very important place to be putting energy. So those are a question and comment.
Thank you.
You can't put it off anymore.
Okay. I love this.
Were you stalling?
No.
She was stalling.
But I was like, well, I have a lot. Like, I don't need much time to make a lot of it. I could just skip most of my time. No doubt.
Sure.
Hey,
Okay, sure, whatever I'm gonna do. So Sandra probably doesn't need an introduction, as everyone knows who she
Everybody's
is.
already seen this presentation.
Not for that reason. Sandra is the director of mass timber at MSU, a program at Michigan State University that harnesses outreach, communications, research, education, policy, and partnerships to advance mass timber construction and manufacture in Michigan and the surrounding regions. She has 2 decades of diverse policy, communications, external affairs, and leadership experience in the nonprofit, public, and private sectors, most of it working at the intersection of climate change, natural resource policy, and equitable and sustainable community development. What's not in her bio, which I think also makes her successful, is a background in theater.
True. I'm actually 400 years old.
And here you could even more of a sense while pursuing a mid-career Master of Public Policy at Berkeley. Sandra caught the mass timber bug in 2016, which led her to work on her master's thesis titled Removing Barriers to Cross-Laminated Timber Manufacture and Adoption in California, a game changer for forests, wildfires, and climate. It is a long title, but it tells us exactly what it is. She sees the opportunity to harness her knowledge and passion and all of these different qualities to help advance mass timber construction and manufacture in Michigan. We're lucky to have her in Michigan, and we're lucky to have her here today. Thanks for joining us.
Hi everybody. Yeah, most of you I've met. All the students, raise your hand, please. All the students who've already seen my presentation, keep your hands raised. Yeah, okay, cool. So there's going to be some things that we'll be skipping here, but I've also kind of made some new slides, so I'm trying some things out on you in practice for some stuff next week. So great to see you all. Really fun to hear some of your presentations. I'm looking forward to hearing the ones later in the day. But what we're going to do is just talk about kind of the momentum that we're seeing growing for mass timber in the U.S. We already talked about that, so I'm not going to. But then in Michigan, and then how we're really working using all of the things Carl said that we like to use: education, policy, research, and stakeholder engagement to get more mass timber in buildings and to create more domestic mass timber production. So our program, Mass Timber at MSU, it does all the things I just said. We're leveraging all the things that Michigan State University, a land-grant university, does. We have a 3-pronged mission to do research, education and teaching, and extension, which is really just a word that we use to say stakeholder engagement and outreach, to advance mass timber construction and manufacture in Michigan, the Great Lakes region, and beyond. And very importantly, we work super closely and with funding from the Michigan Department of Natural Resources, a little bit of funding from the Department of Agriculture and Rural Development, which is a key partner of ours, in the U.S. Forest Service. And all of those entities, right, are very interested in seeing more mass timber production. And in Michigan, right, there's a lot of opportunity to leverage our history of the forest product industry, our ability to make stuff really, really, really well, and support rural economies and communities by producing mass timber. So we'll talk more about that in a while. But this is the part I get to skip, because check this out. They made the same timeline. What is it, 12 monkeys in a room? Yeah, so you know what's happening here. Lots of mass timber momentum building in the U.S. over the past 15 or so years. And this is what the current demand looks like across the United States, right? It's actually more projects than you said. 2,205 projects complete or in some stage of development, construction planning right now, compared with in 2018 just 439. So we've seen demand increase by more than 5 times in just those few short years. And as you said, the demand is expected to increase significantly. And did you say we're expected to 24,000 buildings per year by which year? Amazing. That's amazing. So that's very exciting. It means we need to make a lot more mass timber. But even though we're seeing the demand increase, mass timber currently it accounts for far less than 1% of market share of commercial construction in the United States, which is hard to believe, right? We're building so many buildings, and even though it seems like we're building a lot of them for mass timber, the numbers say we got a long way to go. And so a key barrier, I think, to that, right, is that there's either a real or perceived green premium associated with building it this way. It either does cost more or we think it costs more. And I think sometimes it's one of those things and sometimes it's the other. But I think when it's perceived, there are ways that we can try to address that, right? If we just think it costs more. And one key way to do that is by improving cost estimation, making sure that general contractors, construction managers know how to estimate a mass timber project, because it's very different from estimating the cost of a steel and concrete project. And there are a few different reasons for that, right? First of all, the cost estimating tools that GCs and CMs use do not include mass timber materials. They're new, but they're also not commodities like steel and concrete materials that are able to be captured in those tools. So we've got these prefabricated kits of parts that are custom, and GCs don't know how to get their heads around that. Like, how do we compare steel and concrete to these materials that we don't have tools to estimate? So that's one very important thing. That's also not clear always to new construction managers and GCs that mass timber doesn't require as many finishes, right? So with all the reasons you were discussing about the fire resistance, you don't need to put fire protection on it oftentimes. It's so aesthetically beautiful, you might not need to put additional finishes on it for aesthetic reasons. But a new GC or CM doesn't know this, and so they're just going to include those costs in their cost estimate. And then they also don't realize, or they might have heard that a mass timber building will go up faster because it's a prefabricated kit of parts. But until they've done a project and ground truth that for themselves, they're not going to assume that risk in their estimate, because if that's not true, that's coming out of their pocket. So they're going to want to be really, really conservative in their estimate, right? So for all of these reasons, what we're seeing is early estimates in the pre-construction process are showing the cost of a steel and concrete structural system versus a mass timber structural system. Usually that steel and concrete system is coming back as much less expensive. But mostly that's because the GC was not aware that it needed to work with multiple mass timber manufacturers, really looking closely at their proposed design to get an accurate cost estimate. Do you agree, Michaela?
Oh yeah.
Okay. So this is a really big deal. And so it's very important to continue to educate the people who are estimating your projects. And so as architects, as designers, that's just something to be really aware of. So you can continue to push on that as part of the project, because it's so frustrating, right, to be a designer, be like, this is our beautiful mass timber design, and then have it go to the cost estimating stage, and then have it just get value engineered out. We want to avoid that. So everybody has a role to play in educating estimators. But another way to address this real or perceived green premium is kind of how we've addressed the adoption and efforts to mainstream new green technologies, and that's through supportive policies. New green technologies require supportive policies in order to move from being niche to mainstream. And so we'll just talk about a few things. And some of them are regulations, some of them are incentives, all different types of policy approaches. But the first is to make sure our building codes all over the country are as up to date as possible. And right now what that means is getting everybody onto the 2021 version of the International Building Code, and to be moving quickly into the 2024 International Building Code. This map might look familiar. And this is what that looks like across the United States right now. You can see that Michigan still hasn't adopted 2021 International Building Code, which again identifies 3 new mass timber building types. We're waiting for that. We're now just waiting for like a bureaucratic process to move through, and hopefully we'll have that in place early next year, and then be able to move quickly in 2024. Another type of policy opportunity really is to make sure that mass timber is identified as a tool in either climate action plans, or even that we're creating specific mass timber action plans for different jurisdictions. So, for example, the province of British Columbia has this really robust mass timber action plan. It identifies different types of incentives for builders. It identifies priority investments in mass timber production. It says how much mass timber production that province wants to have. So that's a vision document that then allows people to develop specific policies to achieve that vision. And Ontario just recently completed a draft of a similar action plan that has been able to pass. It would be amazing for Michigan to do something similar. Are you guys all able to hear me in the back, by the way? Okay. I forgot to check. Another type of policy, procurement policies. You know, government agencies, companies have the power to say, we want to reduce the carbon impact of our operations, and in this case of our built environment. And so we can say, we're going to procure materials in a certain way to achieve that goal, right? One example that is pretty recent is last year, the U.S. Army Corps of Engineers adopted procurement policies for all new U.S. Army buildings. So the buildings where people live, the buildings where operations happen, buildings that need to be resilient to like bombing and blasts, you know. They said, we're going to build all those, we're going to prioritize mass timber for all of our new buildings. It's on the menu. It's the top material of choice because of its performance, not because of its sustainability value proposition, but because of its performance and some of those biophilic benefits, because, you know, you want the people in the military to have better buildings. Usually they have really ugly buildings. Let's improve that, right? So the U.S. Army saying that is really powerful, right? That means there's going to be a lot more need for more mass timber in the value chain. So that's pretty cool. But then there's other types of policies that are kind of known as buy clean policies. Does anyone know about buy clean policies? These are policies that, we'll say a state agency, for example, will adopt to help them figure out which products or materials they're going to buy have the lowest carbon footprint. And so when we apply this to building materials, say you're a state, you're building a new building, and you want to know which materials have the lowest carbon footprint. This buy clean is a very interesting policy, and I think it works well for certain types of products. It's based on environmental product declarations, which are documents that tell consumers like what are the sustainability benefits and properties of this product. But the problem with buy clean for mass timber is that it doesn't really incentivize mass timber, because buy clean doesn't kick in to the decision-making process until right before you're ready to buy the materials. So by that time, you've already decided this is a steel building, and you're comparing steel products to steel products. So it's very apples to apples. And so you're not really designing carbon out of the building, you're just trying to choose the best steel for your project. Whereas what is being called build clean, and this is a policy idea that's being advanced by the American Wood Council, and I think it's actually a very good policy. This is aimed at designing carbon out of the building in the design process by doing a whole building life cycle analysis early on, so that you can understand which building system, which materials to choose in order to achieve the lowest carbon footprint for your building. So this analysis makes mass timber highly competitive as a material of choice, right? So so that you will choose early in your design process mass timber over steel or concrete, because you know that's how to get the lowest carbon footprint in your building. So buy clean versus build clean, with build clean being better. But one thing I would say is that there's a way to combine, especially once the mass timber industry is more mature and you have more options for different types of mass timber products with different sustainability properties. We could add buy clean to the end of a build clean process, right? We've chosen mass timber early on because of the whole building life cycle analysis, but now it's sometime when we have available mass timber materials that have like bio-based adhesives that aren't fossil fuel based, right? We can buy clean would help us choose those. So there's ways to combine them, but right now we should be focused on build clean. A few other types of policies, right? From a zoning perspective, we can design policies that maybe make it easier for developers who want to choose mass timber to build higher if they choose mass timber. So for example, the city of East Lansing, which has a very strange sort of development policies in the city. It's very hard to do development in East Lansing. One of the problems is that every single building in the downtown development area requires a special use permit. It has to go through a special use permit process, which is a big barrier. But because mass timber, like think about this, you know, it's a prefabricated kit of parts. It has a much longer pre-construction process than a steel or concrete structure. So if you're a developer working on a mass timber project, you're investing a lot, you're assuming a lot of risk before you even put a shovel in the ground. So you want to know that your building is going to pencil out and that you're very likely going to be moving forward with mass timber. So there's a policy being considered right now in the city of East Lansing. It's going to city council in just a week from now, that says if you choose mass timber for your project, you earn points for that. You can earn a certain amount of points, and you can spend those points on certain types of incentives. One of the incentives is having more floors in your building in a downtown development area where there's a height restriction. timber, you can go taller. And so that makes it appealing for a developer because more floors equals a better product, your project penciling out better. So this is another way that we're looking at addressing barriers to mass timber. The city of Emeryville in California, for example, has a similar policy in place. We can also be looking at just things like tax incentives, rebates, tax abatements. There are a lot of different tools that are available for other types of actions, like choosing solar, energy efficiency, that we could be looking at from a tax perspective. And we can also be looking at grant programs. The U.S. Forest Service Wood Innovations Program, for example, provides grants for a lot of mass timber related activities. Sometimes it's to offset the cost of doing a mass timber design. But they have another group of programs that are really cool. They're mass timber accelerators, and they're starting to crop up in a variety of cities. And these accelerators provide pretty small grants to project teams to offset design costs, say, and then they create a cohort of these awardees, and they all receive technical assistance and work together as a community to try to make their projects go. So there's this supportive community, a little bit of funding that we can kind of help get over that hump and address that green premium. And there's a lot of different grants available, again, for things like solar panels, things like energy efficiency, EVs, all of these different ways that we incentivize those types of technologies. And then something that people always ask about is carbon offsets. Can we monetize the carbon? Can we assign a value to the carbon? And can the building developer own that carbon and sell it on some sort of a voluntary market that doesn't yet exist? People are working on this. It's of interest to a lot of people. Not my favorite approach. A lot of red tape. I think we burn a lot of political capital trying to pass that, and maybe to not as much direct positive impact, but that's something that's out there. And then the other thing I should have mentioned that we should be thinking about as we address barriers to mass timber adoption is insurance. Insurance policies for builders are really, really high. Insurance premiums are really high. And then also for those building owners once the building is built. So that continues to be a barrier that we need to continue to work to address with the insurers, getting them to understand, especially the fire resistance properties of mass timber and how it is very different from stick frame buildings. They're still treating mass timber buildings like stick frame buildings from an insurance perspective. Okay, now I'm shifting to Michigan. So why in the heck does Michigan even care about mass timber? Like, why is the state of Michigan investing in our program, Mass Timber at MSU? Why are they trying to build mass timber buildings? Why are they trying to generate more demand for mass timber? Well, Michigan is a heavily forested state, right? We're the fifth most forested state in the country. Forests cover 53% of our state. We have, as I mentioned earlier, and as Jake likes to mention, a very strong manufacturing and engineering culture, an inherent right to win in this space. Right?
I stole that from a kid.
Automotive, we manufacture manufacturing equipment, we manufacture furniture, and we manufacture forest products here. Our industry employs about 42,000 people, the forest products industry, and produces about $13 billion in economic output. And it could produce more, and it could employ more people if we had more value-added, long-lived, durable wood products like mass timber coming out of Michigan. We need to build stuff, right? We have a 190,000 housing unit deficit, and we also need to build commercial and industrial and institutional buildings, so mass timber is a great choice for that. And our Michigan Healthy Climate Plan, which is the state's roadmap to achieve net zero carbon by 2050, mentions mass timber 3 times as a tool in that toolkit, right? So we already know that we need to achieve net zero carbon. We know we're building a lot of buildings, so we should really be looking to reduce the embodied carbon and the carbon footprint of our built environment. And this is a little bit about manufacture, right? So having mass timber being produced in Michigan is a big priority for the state of Michigan. It's not here yet, right? And you guys had a map too, and this is another version of that map, but you can see where the mass timber manufacturing is in Michigan. It aligns with where the species, the softwood species that are currently certified for use in mass timber in the U.S. and North America. It aligns with where those species are. We've got a lot of Douglas fir over here, some spruce. We've got the black spruce up here at Nordic or Nordique structures. We've got southern yellow pine here, right? Important And then you've got element 5 here, which is using black spruce, and here's sterling, which is using southern yellow pine. So the species wood baskets mostly align with where the manufacturing is. And in Michigan, we have different types of softwood, and most of those materials haven't yet been certified by PRG 320, but there's potential to do so, and so there's efforts looking into how we do that. But this is an important thing. So our program, Mass Timber at MSU, our initial mandate was develop markets for mass timber, get more mass timber in buildings in Michigan, figure out what the barriers are, and help those buildings succeed. So that's what we've been trying to do for the first 3 years of our program, which launched in July of 2021 with the opening of our STEM teaching and learning facility at MSU, which is this building. It's the building on our campus. I think you're going to tour it. Are they going to come? Are they coming? Yep. But you'll see this building. You'll learn all about it when you're there. I'm not even going to spend time on it, but this is an important building. We leverage that as a learning laboratory, especially for the architecture, engineering, and construction industry, bringing thousands of people through the building on tours and learning about what projects they're trying to build, what barriers are they facing, and what do they need in order to make sure that their project that wants to be a mass timber project gets to be a mass timber project. And from that, we are able to track mass timber demand in Michigan, and we also align, we touch base with Woodworks to make sure that our tracking of the demand aligns with their tracking of the demand. But right now we have at least 45 projects in the pipeline in Michigan, all different types of projects all over the state in various stages of development or completion, right? And this is what that looks like approximately, it's a little out of date, but this is what that looks like on a chart. But that's great. We're seeing a lot more demand. When our STEM facility went up, it was only the second building in the state to use cross-laminated timber, right? That was only 3 years ago. So a few examples. I've shown you these before. Adelaide Point in Muskegon on the lake, industrial redevelopment with 2 mass timber buildings complete and near completion, the event center and condos. And then they're also planning to build a mass timber hotel on this site. That was a very ambitious project. I didn't think it was going to happen. It did happen. The AV Ford Community Center, not far from here. Have you guys visited that one? This was designed by Informed Studios with a very community engaged design process. Part of this process really involved community members saying, hey, we really want this building to have natural elements. We want to feel like we're close to nature in this building, and so mass timber was a very good choice. Vineyard View, Sterling's the supplier on this one, right? This is the first affordable mass timber housing in the state. Pretty small townhouse development, but I know that this developer in the Grand Traverse Bay is working on future mass timber projects that might be a little bit larger and affordable. And this is a veterinary hospital in Westland, right? So all different types of buildings choosing to go with mass timber. Now this building, from the perspective of kind of building a mass timber building, getting more mass timber in buildings in Michigan, and kind of contributing to the future reality of mass timber supply in Michigan using Michigan wood is a very important project by the Department of Natural Resources. This is in Newberry in the Upper Peninsula, and it's a new community services building. It's almost done. It'll be done. It'll be done really, really soon. And the cool thing about this building is it's the first building to use cross-laminated timber panels made from a Michigan wood species, red pine. But we don't manufacture mass timber in Michigan, so how does this even happen, right? Amazing. The architects, Lord F. Sargent, who are not here today, but I thought you might see them, worked with Vaughan Timbers out in Washington State to do the product research and development and design and testing and certification of CLT panels using Michigan red pine, right? So red pine was shipped from Michigan to Washington State. This is not how we always want to do it, but it was shipped there. And then the panels were shipped back and they were put in this building. But what's cool about this is now we've proven that we can use Michigan red pine in a mass timber product, and it's been certified. It has a PRG 320. So if somebody does want to make more mass timber materials using Michigan red pine, they know that it can be done and that they won't face a big technological barrier to doing it. So this is a very important project. So, as I mentioned, 45 mass timber projects in the pipeline, but right here is like where we really need to be providing support, like technical assistance, policy, because we want to make sure that these projects don't have mass timber get value engineered out. So from a policy perspective, happy thing. We did a survey, we participated in the State of the State survey, which is a are under 50 and with higher levels of education and higher incomes, but even more supportive. So that's just some interesting data that we're able to collect. People are talking to policymakers, they can say, well, it looks like there's support for this. And here's what's emerging in Michigan. I already mentioned the My Healthy Climate Plan. Some cities Lansing is taking mass timber into its sustainability action plan in a similar way to what the state did. The Ann Arbor Public Schools are saying we want to build all of our new schools with mass timber and are specifying for mass timber and requests for proposals. We got the Michigan Building Code in process. I mentioned the East Lansing ordinance already. And then there are a few developers who are working with the lobbyists to advocate for tax incentives, tax credits, grants, new policies that really make it easier for us to choose mass timber in our buildings. From a more community, like mass timber community development, ecosystem development perspective, mass timber at MSU does a lot of different things to bring people together. I'm telling you this so you'll want to go and join us this year. We organize a Michigan group to go to the International Mass Timber Conference in Portland, to go visit Alexis every year, and go shopping in her stores that she likes. But join us in March. We take a group with us. They have rather good student rates, so if you can find some travel funding for students, please join us for this. We usually have a group of 50 or more people from Michigan who attend this. And if you do, you get to fly into the new terminal at the Portland International Airport. It's made from beautiful mass timber with mass plywood panels in the roof. A 9-acre roof. That's a big project. Did you fly out of there?
I did. I've flown on it twice. It's beautiful in person.
Super cool. So looking forward to seeing it finished, and you should see it too. And then in December, we host the Michigan Mass Timber Update. This is an event where people come together to really celebrate and discuss the mass timber momentum that's built in our state over the past year. So this will be December 10th this year at Adelaide Point, the development I mentioned in Muskegon. If you'd like to come, send me a message and I'll send you an invitation. We would love to have you. And then another important thing that we do is we convene this virtual technical assistance and peer learning space, which we call the Michigan Mass Timber Community of Practice. This happens quarterly and was an idea that emerged at the first Michigan Mass Timber Update that we held. So we decided we would really try to do this, and so we worked with Woodworks and the American Wood Council to bring folks together, again on a quarterly basis. They hear like a subject matter presentation, and then there's an open hour, which is basically office hours, so people can bring all of their questions and ideas and ask them to us, the people who are hosting and staffing the event, but also, and more importantly, get input from their peers and just develop a collaborative learning environment that supports all of us, right? Because if we either all succeed together in this mass timber adventure, or we all fail. So it's a collaborative moment. And then at MSU, we also have a mass timber resources portfolio that I did not go into much last time, but I wanted to spend a little time this time. So one of the key barriers to mass timber adoption everywhere, right, is people are coming out of college and community college without any exposure to mass timber. They don't learn about it. You're fortunate you have a mass timber studio now. That is amazing. Most places don't have that. So we've gotten a grant from the National Science Foundation to develop curriculum modules that architecture professors, engineering professors, construction management professors, and carpentry professors at community colleges and universities across the country can select modules and drop them into their existing courses in those disciplines so that they're exposing their students to mass timber more easily, right? They don't have to create an whole new class. They can adapt this content however they need to, but we wanted to make it really easy for people to be able to start exposing students to that. And this is a really cool project because we're working very closely with professionals in all of these different disciplines to find out what do you need students to be coming into positions with your company to know? What skills do you need them to have related to mass timber? So we're expecting to have something that's really, really, really driven by industry needs that can then be adopted by educators across the country. In order to understand or to help prospective mass timber producers understand the landscape in Michigan, with funding from Michigan DNR, we're conducting a Michigan mass timber supply chain analysis and a Great Lakes region demand survey, right? And I'm not going to take a deep dive here. We'll be rolling these results out, I think, as early as next October, like so soon. So the different questions that people have. In the meantime, we've been working with funding from the U.S. Forest Service to demonstrate in the DNR's building that use Michigan red pine actually got ahead of us and got it done really fast. But before that, we started working on this project to demonstrate the use of Michigan red pine in nail laminated timber panels in 2 buildings in the UP. And the reason, and these are the buildings, the Great Lakes Boat Building School, which is they teach people how to make wooden boats, so why not do it in a mass timber building? Super cool. And then this project in Marquette called Shop House Park. But we really wanted to show, right, that we have the potential to do nail laminated timber, right, which is a material that you don't need to have a big factory to make. You can make it on a project by project basis. You don't need a lot of people to make it. So it's not a big capital investment, but we can start doing it now, and it might be even an appropriate kind of super regional economic development opportunity. So to support forest management goals, to increase carbon storage, to offer workforce training opportunities, but then also to demonstrate and communicate that we have wood in Michigan that can be used in mass timber materials right now, even if they're not cross-laminated timber or glue-laminated timber, right? We can make NLT, which has been in the building code for a really, really long time, and put it into appropriate projects. So we're excited about that. And then finally, when we were talking about kind of mass timber and next life and kind of biodegradability, I mentioned that we really need to be thinking about the adhesives that we're using. One of the areas of research that we're really proud of at MSU is led by Dr. Mojgan Nejad in the forestry department. She and her lab are developing adhesives and coatings for mass timber that are made from lignin, which you probably know is a waste material from the forest products industry and from the agriculture industry. So this replaces the fossil fuel elements of adhesives and makes the adhesives biodegradable and sustainable and actually super cheap to make. So right now she is working with Element 5. She has a partnership with Element 5 with their test techniques on the manufacturing floor. They are proving to be extremely strong. The adhesion performance has actually been better than the existing adhesive. And she tells me that the cost is 5 times less than the adhesives that they're currently using. How much of your product cost is attributable to adhesive, would you say?
It's pretty small, and actually we're working on the next round of this with her.
Oh,
so
we don't communicate internally.
Yeah, we don't talk a lot. No, I'm just kidding. The cost overall is pretty small, but it depends on how scaled you get. So obviously for us at large scale, it can be a pretty significant cost.
So it could help.
Oh,
in
yeah.
the long run, bring down the actual materials cost while creating something that is biodegradable and then maybe has a greater potential of moving into a next life more cleanly. So that's what I got for you today. And my conclusions are really high level. Mass timber demand and manufacture are growing across the United States, but we need more supportive policies to help make that happen more rapidly. The AEC industry, developers, code officials, policymakers, everybody needs ongoing technical assistance and education. We just had State Bureau of Fire Services in our building on Thursday, yesterday, for an emergency training because I realized that they didn't know really important things to approve or to review projects that were coming across their desks right now. It's okay, we got to settle this right now. So there's a lot of technical assistance and education needed. We do need to increase domestic production in the U.S., but especially starting value-added fabrication to help remove that part of the supply bottleneck, and then be ready to move into and add more volume of panels and columns to production. And of course, universities, MSU, Michigan Tech, which I should have mentioned, is doing R&D. Where'd that go? Oh, there it is. That you mentioned, Michigan Tech is doing R&D on hardwood mass timber materials, super important. And now LTU, we're all adding significant capacity and growth in this space. So lots of opportunities to collaborate, a lot of work to do. So keep it up.
Jake,
Sorry.
you have a question?
I did have a question.
So how about
I'll wait.
you set up, ask a question, and then we can change over.
I was just curious about you guys talked about specifically using just red pine for that, and red pine's part of the SPSS South
Yes.
species group, and so I was curious if you guys are looking at sourcing exclusively red pine, or are you looking at anything in that group?
Openness to all.
Openness to all.
Yes, but the red pine went first because
Yeah.
it's available and ready.
Yeah, for sure.
But yeah, all of it. Good.
Well,
Yeah.
let's make it all. You know, I'm ready. We're certified for spruce pine.
I know you are. Sterling is certified for spruce pine fir south, which is the species group that's most plentiful in Michigan when it comes to softwood.
Now you just have to compete with me in Wisconsin.
All right, Jake is up next. Jake Chester is a cross-disciplinary creative problem solver, designer, and educator with a 20-year background in areas of real estate development, inclusive urban planning, commercial, multifamily architecture, asset positioning, historic preservation, community engagement, marketing, leasing, and economic business development. Well, but the conversation when we started was like, oh, what's your role now? It's different from what it was before. Jake has held many roles at Bedrock. He's the VP of the Office of Urban Strategy and Innovation. That's still true.
Yeah, since yesterday.
Which is an agile think tank within Bedrock tasked with exploring innovative urban strategies. He's currently a fellow with the World Economic Forum Center for Urban Transformation. He's been an adjunct at LTU, and he's also an alum of LTU. So thanks for joining us today.
Absolutely. So yeah, you work at a company long enough and you just start to forget what your job is. It's increasingly complicated. So I used to kind of be an architect, and then I was design director for Bedrock. And now I guess I'm just a developer, right? I think a developer is just something that you fall into when you learn how to manipulate enough systems to like hit a shovel in the ground. And I didn't actually finish this deck until this morning for a couple reasons. One, as architects, even as you get further and further into your career, everything is still very last minute, right? You address deadlines as they approach. I had deadlines yesterday, today's the presentation, so a couple hours ago I finished this deck. Two, I wanted to see some of the other presentations happen, so I wasn't being duplicative, although having seen Sandra's just now, this one is somewhat duplicative in stuff that you just talked about. But three, I'm by no means an expert on mass timber, on forestry, on forest products, on manufacturing. Like I'm just a developer. So I really had no idea what I was going to talk to a group of students and then some members of the public about. So I figured I would just talk really about one thing that I do know, which is building here in the city of Detroit. Right, I'm pretty good at that. And it's a really good narrative too over the past day and a half, where we started pretty broad. We talked about mass timber at the national scale, and forestry and forest products at the national scale, and then Sandra was talking about Michigan, and now we're kind of like narrowing down this aperture a bit. So let's talk about Detroit, and I'll talk about why and how, as a developer in the city of Detroit, I'm thinking about using mass timber and the value proposition that this methodology offers me, and how I'm sort of selling this sort of upward through the chain to my stakeholders, if that makes sense here. So before I get into that, I did want to point out something about this space. And Mason and Churchwell, my colleagues are here. This is an opportunity to thank them. Is that we used to use this space every year for like design discourse like this, and it's been about 5 years since we've had the opportunity to do this. This is fantastic. So thank you to them, thanks to LTU for putting this on. In 2017 and 2019, we used this space during the month of design for DD 139. It stands for Detroit Design 139. 139 is the 139 square miles that is the city of Detroit proper, right? It's a massive city. And we started doing that in consortium with the planning department and with Design for Detroit to celebrate our UNESCO designation, which we talked about a couple of times here. The thought was, okay, we got this great UNESCO designation. We're the only city in the U.S. that has that designation, but for the plus or minus 600,000 people that live in the city, they're like, okay, well, who cares, right? Like, I'm just a person who lives in the city. There's a UNESCO designation. To me, that just means a bunch of academics like kicking around some idea, like how does that impact like my daily life? And the idea of this exhibit was like, good design is not just happening here in downtown Detroit. It's not just happening in academia. It's also happening like throughout the 139 square miles that is the city. That's why we have the designation. It's happening, on murals inside the building. It's happening in bodegas and church basements and parks and community centers. Like it truly is imbued in everything that the city is doing. And then pandemic happened, stopped doing that, lost some momentum, some critical people left, and now we're back here in 2024 having great in-depth, design discourse in this space. So let's not wait another 5 years to do that again. So thank you. Before I can talk or think about why Bedrock is really working to push mass timber for some of our new developments, the work that we're doing with Sandra, to get it there, I need to sort of step back and maybe explain sort of what Bedrock is, our path to how we got here today, our footprint in the city, and our development sort of ethos and methodology. So we're going to talk a little bit about non-mass timber stuff, which I think is both, I think a welcome break, but also very necessary to lay the foundation of how we can think about sort of intervening within the entire sort of value chain, supply chain of timber in this capacity. So first of all, Bedrock, the development company that I work for, is a full-service real estate company. Now, what I mean by that is that we have in-house sort of all of the subject matter experts to build, right? We have in-house construction, in-house architecture, in-house development, but also the mechanisms to maintain the built environment. So we have property management, we have commercial and residential leasing, we have security, we have the engineers to keep the buildings functioning, to work on the HVAC systems, to clean the windows. We have sort of everything that keeps the systems up and running. We, and this is one of our mission statements, we're developing economic cityscapes, we make community, we invest in creativity and city pride and all that good stuff. The other big point here is that we're not just involved in the creation and the maintenance of place and space, but we are also couched in a much larger enterprise here. So our chairman is Mr. Dan Gilbert. If you're from the area, you've probably heard of him. If you're not from the area, maybe you're not familiar with him. He owns Rocket Companies, which is a mortgage provider. He is also a majority shareholder of the Cleveland Cavaliers, the NBA team in Cleveland. And he also has positions in over 150 different companies. So StockX, that's Internet of Things, that's the verified sneaker company. He owns a couple design firms. He owns some random ones like Dictionary.com. We own that because why not? We own the Rob Report, the magazine on culture. We own a few tech startups, right? I think that's important to sort of set that foundation that like our chairman is a serial entrepreneur that will invest into companies that add value to the larger sort of vision of building, creating space, creating ownership, creating culture, creating gaming environments. If there is sort of a glide path to that level of value creation. And then some high-level metrics that enterprise, we call it the family of companies or the FOC. You'll see a lot of references to the family. There's like some mafioso kind of things that are usually peppered in there. The total portfolio is $20 billion. I only own like 1 or 2 billion of that, so it's not that prestigious. That was a joke, by the way. There's 18,000 team members, employees within that enterprise, and we are headquartered here in Detroit. Okay, so now we're going to sort of pivot to our portfolio here. Originally, this company was headquartered in a suburb. I've been actually living downtown in Detroit for almost 20 years now. So I came to Detroit before this whole sort of momentum sort of shifted that we see sort of culminated here today. But this Dan Gilbert enterprise was in the suburbs. And he was losing employees to other markets, right? Because young, creative people don't want to work in like Livonia, right? You drive to work, you go from a condo, you drive to work, you park in, a surface lot with 1,000 other cars. hours, you do your 9 to 5, you get back in your car, and then you go to your condo, right? And young people are like, well, this sucks. All my friends live in Chicago and Austin and New York, and I want to live and work and play in a place that has culture. So he originally moved his company, that building right across the street, as an effort in talent attraction and retention. And Bedrock, my company, was formed as really an entity to buy and upgrade and maintain office space for a banking population. So it really just started looking like this back in 2010. And that was successful, so this flywheel started to grow. So you move another 1,000 people downtown, right? And then other office tenants and companies that were sort of scattered throughout southeastern Michigan kind of saw this momentum and say, oh wow, this company is actually moving downtown. We should also move downtown because it seems to be working. Like he seems to have this sort of formula for talent attraction and retention. So then Bedrock, my company, grew. Instead of just leasing buildings, we started buying buildings because again, at this time in 2012, it was much cheaper to buy buildings in the city than it actually was to lease them. I mean, pennies on the dollar here. So then we get, Fifth Third Bank moved downtown, Ally moved downtown. Again, these are mostly financial institutions at that time. We started building a couple parking decks early on because that's still the main mechanism by which people sort of in the surrounding Tri-Town area and beyond come to work downtown and then leave. And then once the daytime population starts to increase, now you need those amenities for that daytime population. So now we get into the food and beverage asset class, right? So we buy more commercial buildings, and then we get into maintaining, leasing, building out, attracting tenants to really build out that ecosystem. Now people want to live downtown. They're already working downtown. There's more amenities downtown than there were previously. So we start building out multifamily spaces. And then hotels, right? Because business is up, people are living downtown here, there's more stuff to do downtown, so then we build out hotels. And then we start going with some new construction with the Hudson site, which is just north of here. And then there's vacant land aggregation. And then some more vacant land aggregation. And then in 12 years, we go from not being downtown at all to owning 120 properties, 18 million square feet, and deploying $6.5 billion. There really is no other model that I have seen in North America that looks like this. And it's a very unique sort of real estate development investment profile, right? Most real estate developers do sort of strategic plays across very specific asset classes in very specific markets. So it'll be like, okay, I think the next hot market is going to be, northeast of downtown Austin, so I'm going to build a multifamily building there, and I am going to make 12% levered cash on cash over 5 years or so. Then you make that investment, right? Or maybe it's going to be north of Dallas, or it's going to be in this location. You sort of piece together a portfolio of these strategic markets, and you try to beat out, say, the stock market or something like that, right? Our investment portfolio profile is let's aggregate densification here, right? And then if we can control various blocks, and we can program each block sort of like you would program an entire shopping center or new downtown, we can ensure that the right tenants go to the right location at the right time, that we put parking in the right place. Not every building needs its own parking deck, like one block can share an entire parking deck. We can ensure that things come online at the right time to optimize success for the right retail tenants, to make sure that the right density of hotel users are next to the right density of food and beverage operators and so forth, really to optimize success of the entire portfolio. And it looks something like this, where we own many of the historic assets across downtown. So, what does this have to do with mass timber? Well, the punchline is that it doesn't. And then, really, over the past 15 years or so, we really have not had to think about innovative construction methodologies or typologies technologies from a structural standpoint, because almost everything that we've done has been adaptive reuse or historic preservation of 1920s to 1950s mid-rise, high-rise buildings. This is a bedrock building, right? And is that one. Albert Kahn, 1920. That street is later Albert Kahn, 1950. The third building over there, that's Yamasaki, 1961. This is Smith Group. Here, this was 1963. Like, it's been, like, this is what I cut my teeth on. This is why I came to Bedrock. Like, I love this stuff. I'm excited about this stuff. But this is not, like, new out-of-the-ground construction that requires innovation from a structural standpoint. Much of the innovation has really been, from a technical standpoint, in, like, MEP systems, right, to be, like, sustainable in those approaches. Certainly envelope, facade restoration, and glazing, and things like that. But we have not really had to look at things like mass timber at scale. We've done a ton of this stuff too, which has been placemaking, right? The spaces between the buildings. We own so much of the architecture here, but if you're not, curating sort of the user experience of your space, that sort of phenomenological approach, like they're just edifice and they're not place. So we put a lot of time, energy, and money into activating place between space, but we have not done a lot of this, right? New mixed-use, mid-rise, neighborhood infill and densification. This is the exception. This is the City Modern project, which I had the opportunity to work a little bit on, in a community just north of downtown. Which was actually probably about 80% complete, but we finished in a couple years. And this is what most cities have been doing, right? When we think about city sort of densification and expansion, when we think about those aforementioned markets, Austin, Dallas, Fort Worth, Portland, whatever, this is what most cities have been doing. Detroit is very unique in that we had such a fantastic stock of old buildings that needed a lot of work, and we could spend the last decade on improving things. But I think that's changing, and this is where the opportunity is. This is our East Riverfront plan, and this is sort of a sneak peek of what we'll talk to the student group on during lunch. This is where the 5 sites for the studio project are located. We are now at this interesting influx point, both as a company, and I would say to some degree as a city, although I'm always very hesitant to have Bedrock represent the city, because those are two very different entities. As I said, the city is 139 square miles. We mostly develop in the central business district, which is 1.5 square miles, so it's like less than 1% of the city that we're active in, like from a development standpoint, although we have other interests outside of the city from like a community stabilization standpoint and a single family foreclosure assistance standpoint and things like that. But now we're finally starting to do like full neighborhood planning to go vertical at that scale. And it's because of this, right? We have gone sort of very systemically since the mid-60s, really I'd say 1970, from a city of demolition to a city of planning to a city of building to a city of growth. We did a lot of good planning exercises in the early 2000s, and I was a part of some of these very early on in my career, but then we had that recession in 2010, right? And then in 2015, we were finally able to become a city of building. We had like this great intersection of a few things. We had our UNESCO City Design designation. The city of Detroit went through bankruptcy, largest municipal bankruptcy in North America. And then we got, come out of that, we got new leadership at the city of Detroit, got on sort of the Kwame years into the Duggan years. Bedrock came here with the dams, and then Olympia, the stadium over there, started infusing some capital into downtown, and we were finally able to kickstart some of this downtown development. Now, 10 years later, we're 10 years out of bankruptcy. We have an investment-grade credit rating, which is crazy. For the first time in 60 years, we have a stabilized population. Like as the last census tract just came out, for the first time in 60 years, this city has not lost population. Like that's crazy, right? And then there's this awesome opportunity for federal, state, and local incentives for grants and taxes and things like that. So we have this next sort of round of culmination of opportunity that positions us for city government. So looking ahead, right, blue there is the downtown. We have now, under our control, a few different, we'll call them economic planning districts, where we have a control density that allows us to put together, vision documents and very thoughtful, we'll call them early stage master plans for what these communities can look like. There's one to the north of downtown, which is the Brush Park Douglas area, one to the east of downtown, which is the Gratiot District, and one to the southeast of downtown, which is the Riverfront. And as we think about going, vertical at this sort of neighborhood scale, like I say, there's two ways we can do this. We can do it like the simplest and dumbest way possible, or we can do it sort of like a more thoughtful approach. The simplest and dumbest way possible, this is a gross oversimplification, but would be, this 4/1, 3/1 podium construction, right? And, Pat yesterday did mention, and I think very, very truthfully, that it does use a lot of wood, right, which is great, and that wood is going to come from half a dozen mills or so that are going to be located here in the Great Lakes area, and that, woodshed is going to be from 100 miles from those mills, so it is all very much a localized product. But the challenge with this podium construction, from my perspective, is it just leads to mid-use or mid-rise mixed-use mediocrity, right? It's kind of placeless. It all looks the same. It looks like all of those markets, and it looks like also the markets that are just outside of Detroit. It looks like Royal Oak. It looks like Farmington. It looks like Birmingham, right? And it's sort of this broad brush placelessness of the areas that are just outside of downtowns or midtowns, right? It's cheap, it's easy, we know how to build it, but it's not sort of defining character of hyper-local markets, right? So we have to be able to lean into product differentiation, I think, in order to make these communities unique, authentic, local, and ultimately attractive to lease, to buy, and to invest in. The other challenge we have when we're going vertical at scale here is this math problem where the math doesn't math. And the business students aren't here today, I don't think. But every developer in Detroit will tell you this, and they're true, and no one has sort of the solve for it. But innovative construction methodologies can be one solve for it, is that pound for pound, it costs as much to develop a building here in Detroit as it does in a more competitive market like Chicago, right? It's going to cost, and one of the student groups, I think it was the business student group yesterday, pointed out, it's about $250 a square foot to build a building. You add in all of the development costs, which is going to be the hard cost contingency, the soft cost contingency, the developer fees, all the insurances, probably close to, I'm going to say $450 a square foot, right? You can't really get around it. You can maybe, save $30, $50 here, one way or the other, but ultimately that's going to move me, I don't know, 30 to 40 basis points one way or the other on returns, right? So you're kind of locked in there, right? Even if you can save money one way or the other by using timber or something. The challenge is we cannot command rents, the same sort of rents here in this market that we can in Chicago. It is what it is, right? In Chicago, if I'm going to rent an apartment on the riverfront Chicago, I'm going to probably get a new high-rise building. I'm probably going to get $6 a square foot, right? So if I have, 1,000 square foot apartment, I'm going to be able to lease that for $6,000 a month, right? No way in hell I'm doing that in Detroit, right? It's because there's just not enough people in Detroit. People candidly don't make that much money here in the MSA, the metropolitan statistical area, and there's enough options that are less that no one's going to upgrade that option when I can rent something for $2 a square foot or $2.50 a square foot, right? So when I sort of put this all in the shaker and I shake it up, it's going to tell me I can only charge this much if I want to lease it up at this rate. So the challenge here is that when I do all the math, it tells me that the return on any project, even if I'm an investor like Bedrock, where my goal is not to make a quick return, we don't flip projects. We hold on to projects for a long time, if our goal was just to make money, we wouldn't be doing this in Detroit, we would be doing this in a different market. Even if I'm a really socially minded developer, my returns are going to be like what? Like 3%, right? A federal 10-year T-note for a treasury bond is going to give me like 3.5%, meaning I could make more money by taking that same amount of stack of dollars and giving it to the federal government and then sitting on my ass for 30 years, right? Then I could doing all this work and develop housing, right? So how do I beat that? Now that's a very complicated question, but one of the tools here is that we need to provide product differentiation, right? That goes back to eschewing this idea of mid-use, mid-rise mediocrity, right? Is that if I can provide a variety of different product types, have to be cost effective, it has to work at scale, and it has to be done pretty quickly, is that I can appeal to different user segmentations. And that there's going to be different users are going to pay a certain amount, sometimes higher, hopefully, for something that fits to their sort of level of interest, right? Mass timber is not going to be for everyone. But we believe that there's going to be enough people that are going to be attracted to a mass timber. I'm talking about multifamily, or maybe to some degree office or hotel as well, that they're going to seek that product out. It doesn't exist here in scale in Southeast Michigan. They're going to seek that product out, and they're going to find it. They're going to want to rent there at maybe a slightly higher cost. It's going to fill up quicker, even if it's not the cost that I totally want at the end of the day. And that product is going to be successful because I'm leaning into something that's different, something that's unique, and something that satisfies the value system that people have, right? So how do I get there? Well, in addition to that product pipeline, which you have there in green, if you go back to the beginning of this presentation, we're not just a developer. We are part of a much larger enterprise that is very comfortable, that is, if proven value, can be comfortable with investing in other parts of the system. We believe that we should also be investing into supply capacity in Michigan, in the Great Lakes region, to basically lock in price of mass timber components to help satisfy this project pipeline. And this gets into some of the work that we're doing with Sandra and this consortium. I don't necessarily need to go into all the benefits of mass timber. You guys have seen this again and again over the last couple of days, that it's cost competitive, that it promotes diverse environments, that if you want higher rental rates, you can probably get them, that it's local and you can mitigate some supply bottlenecks. This is what Sandra touched on very well about a half an hour ago, that why should we bolster supply in Michigan? Well, we have universities that are really looking into certifying some of the native species here. We have a history of logging and manufacturing in this region. We have that right to win, geographic capability. We're the fourth or fifth most forested state here. We have existing mills here, so we're really just looking at additive manufacturing rather than sort of baseline manufacturing. And if you combine those two things together, the value of building with timber and the value of investing into timber supply chain, you get sort of this quintuple bottom line as a developer. If as a developer you have a stake in both of those, both sort of the end state and the supply, there's a myriad of benefits here. You often talk about the triple bottom line for a business, which is profit, planet, and people. I'm suggesting here that not only can you make money here, but your product will absorb faster, it's good for the environment, you actually are helping the planet through better, forest management and conservation because you're investing into that whole part of the system. I'm actually saying that, there's a national security benefit here because you're taking away from a dependency on foreign steel and you're sort of re-onshoring an entire product. And there's an economic benefit play here because you're not only contributing to jobs from a urban standpoint through new construction projects, you're actually creating rural economic development as well. And if you can create rural economic development and urban economic development, you don't need to get political here, but there's like a red and blue thing going on there that no one's doing that could be huge, right? We don't need to get into this. So, so you start to pick this apart, and it's like, okay, well, how can, Jake, again, this is wife, and I started saying, like, I don't really know what my job is anymore. How can I, Jake, like start to piece all of this together? It's like, okay, in order to like really build sort of we'll call it stump to apartment building, Bedrock has some sort of share in all of this program. It starts to get pretty complicated, right? In the forest, you've got the manufacturers and or fabricators, project pipeline, like we have some of that. You really need about $1 billion on the project pipeline to make the whole thing work, and we don't have quite that in mass timber. Yet agency support, Sandra helps out with that. You need to have some real estate to support, a fabrication facility. We have that. But if you want like manufacturing, that's going to be sort of outside of the central business district. You need operating partner, workforce training, research partners, and then it's like, okay, so this becomes much bigger than something that I can handle. So then you come up with these two theses, which is one is, well, if I have this problem, I'm probably not the only person with this problem, right? And if Michigan has this problem, it's probably not just Michigan, right? Within the Great Lakes, Michigan is probably not the only state that is trying to sort of leverage its right to win in terms of manufacturing of mass timber types of products and building with mass timber types of products. And if that's true, then each individual state within that Great Lakes region doesn't need to solve for all of these, right? Maybe, Michigan has, the research component and the design component. Maybe Minnesota has the forestry component. Maybe Ohio has the political will to sort of pull from the federal government. Like, let's just all find sort of the areas in which what we're good at, put together, sort of this Great Lakes championship team, and then use that to compete with the Pacific Northwest, the American Deep South, the Quebecois, and become this region that can actually start to be on the map, right? And this is not something that we just came up with out of nowhere. These two other regions have already done it to some degree. Sandra mentioned BC. Again, that's a province, not a region. We're getting a little bit bigger than that. Kenya started to do one as well with my work with the World Economic Forum. But there's a platform for this. So we're leveraging our U.S. Forest Service Wood Innovations Grant to assemble the Great Lakes Mass Timber Consortium. We identified a state lead from all of the member states. We're having a convening in about a month here in Detroit, pulling about 100 people to that to basically identify all the needs of each of the states, identify where we have opportunities to excel, and then publishing one of these action plans as a way to kickstart this ecosystem to ultimately get us on the map in terms of supply and then hopefully demand as well for mass timber construction. And then, I'll finish it with this. Again, one of my favorite sayings that I stole from McKinsey, which I'm allowed to do because they charge, like about $500,000 for every publication they do for us. So I can pull it for them. Is that, Michigan, Great Lakes region, has like a right to win in this space, right? We have a history of timber harvesting, logging, and then manufacturing in this region. Tiny cities in the UP, like Calumet and Escanaba, at one point were more populous and wealthier than Detroit because of extractive industries like this. Now, obviously, those were not set up to be sustainable. They fell apart. They were not, properly transitioned into the 21st century. But like the know-how is there, right? To know how to do this, right? This is the road to Detroit. Michaela, that's industrial matting there, right? That we did, 150 years ago, right? Like we know how to do this in this region, right? In terms of vertical integration, right? It's the Model T, Model A. Henry Ford owned the forest in the UP that went into the woods and trim in his automobiles. Same thing with Michigan Bell, that became Ameritech, that became AT&T. They own the red pine forests that Sandra is working to get certified, that are now certified for utility poles to get their phone lines to go from the rural towns in the UP to here in Detroit. So this is all something that we did 100 years ago that we kind of just forgot how to do to some degree, that I think we can get back there. And then I'll leave it with this. I found this rendering while I was putting together the presentation to recognize this space. This was from Smith Group in, I think it was 1959. This actually used to be a bank lobby. So, thank you for your time.
Hi everyone, we are the commercial group. My name is Kate Lamera. I'm sorry, I think you do need the mic. At least from way back here. Only because of that.
Hello, hello, okay. Hello? There we go. Good. Okay. Go ahead. So today we will be introducing what is mass timber, the history of mass timber, how mass timber is being integrated into design in Michigan. We'll go over a quick case study of Albina Yard, and then we'll go into our manufacturers. And then we will discuss some key code information, some standard structural grids, programs of commercial spaces, the economics of mass timber, the sustainability of mass timber, how mass timber is delivered, the health and wellness, occupant experience, and material considerations that go into designing a mass timber building, and then we will end with some precedent studies. So to start off, what is mass timber?
So mass timber is a bio-based engineering wood material made from the heart and sap of spruce, Douglas fir, pine, and western hemlock. The following map shows their distribution in the U.S. Mass timber comes in various types. The main one we'll be discussing in our precedent study are glue laminated timber, where wood is glued in layers running parallel, and parallel strand lumber manufactured from wood bonded with adhesives. Moving on to the history of mass timber.
So mass timber as we know it today didn't really start until, mass timber as we know it today didn't really start until the early 80s, but it wasn't until the 2000s that it started gaining momentum in North America. And then in the mid 2010s is really when it started taking off. And here we see those projects that were key moments within the 2010 takeoff period. And generally, here's just some of the reasons for the growth of mass timber, but it all boils down to just developing the tools needed to manufacture the product and having methods in place that allow for its use, like code, for example. And here's just a quick look on the first project in the United States to use domestically made CLT. However, we go more in depth into this project later on. So now moving into what's happening specifically in Michigan with mass timber.
So I just wanted to provide some quotes. So according to the DNR, Michigan has more than 19.3 million acres of forest. Softwoods like aspen, pine, and spruce also commonly grow in the state. And there's enough forest resources in Michigan and the Great Lakes to support Michigan-based mass timber facilities. So looking at the community center at A.B. Ford Park, it was the first climate resilient community center in Detroit, Michigan, and it was just completed in 2023. This is a cross-laminated timber building that also utilizes solar panels. This is the Griffith Veterinary Hospital in Westland, Michigan, and it was also just completed in 2023. This building focused on biophilic design to comfort the pets and families. This building uses cross-laminated timber and light frame construction. And this is Southtown in Ann Arbor, Michigan. It is a mixed-use mass timber building that is 8 stories. This is an energy-efficient building using arrays of solar panels and living roofs. The mass timber structural material used was the cross-laminated timber. This is not completed yet, but it's undergoing by Simniki. And here is a quick case study on Albina Yard to kind of introduce our general research. So all of the wood for this project was harvested in the Northwest by D.R. Johnson. The wood was manufactured to 1/8 inch precision, and it was shipped only 200 miles to the site, and 4,000 square feet of the CLT was installed in less than 4 hours. So they used a 20-foot by 20-foot square structural grid, and that originally called for a 7-ply, but using an intermediate beam going down to a 20 feet by 10 feet, the CLT could go down to a 3-ply. And here's just a look at the 3-ply. They also use 4-foot cantilevers with the 3-ply, and the window wall system also uses the structural Douglas fir. And then here is just a diagram of the structural
components that go into this building. And now introducing the mass timber manufacturers.
So we selected 5 manufacturers to focus our research on. However, for sake of time, we'll only be looking at 3 of them today. So StructureCraft was our primary, and they offer a wide range of products. However, we found that CLT, GLT, and DLT were the most common for the commercial typology that we have. And then Element 5 offers some more interesting products, such as the Nano CLT, which is basically just an ultra-thin CLT panel. And then they also have clips, which are insulated CLT panels. And then finally, Ferrous Engineered Wood, which has mass ply panels that can be used for shaft walls. And it's also advertised as a competitor to the typical CLT panel. And now we're just going to do a brief look at code. So the newest IBC came out in 2021, which does have elements that relate to mass timber construction. However, we can see that it's not 100% adopted yet nationwide. With this code, though, they do feature new building types that specifically cater to allowances for mass timber construction, which are 4A, 4B, 4C, and 4HT.
So just quickly looking at fire, when mass timber burns, a char forms around the wood, which acts as an insulator, so the wood on the inside can maintain its structural integrity. And now we're going to look at the standard structural grids when designing with mass timber. The most typical are just square and rectangle. Here's just a little graph that kind of just shows kind of the typical sizes. And again, I just wanted to go over the intermediate beam. Here, the column grid was originally spaced at 13 feet 4 inches, and that used a 5-ply panel. But by going down to a 10-foot structural grid, they went down to a 3-ply, and this was 25 to 30% reduction in the structural material. And then this just is a little graphic showing the different plies of the CLT.
And this is just quickly showing how the various combinations of systems play a role in not only the form, but also the grid needed to create that aesthetic. And then there are a few options when it comes to MEP integration. One is raising the structural system and running those lines in the created space. Another is cavity systems, which integrate those systems right into the mass timber elements. Or we have floor systems, which integrate directly into the top of the floor systems or below in a raised access floor. And now continuing with typical programming of commercial spaces.
So we looked at industrial, office, and retail spaces within the commercial programs. So first off, industrial, I noticed that small programs are typically less than 15,000 square feet, but larger programs can go up to 100,000 square feet. And in offices, I just found that about 100 to 350 square feet were provided per person. And with retail, malls can be up 400,000 to 800,000 square feet. Strip malls are plus or minus 30,000 square feet, but big box retailers can be anywhere between 30,000 and 200,000 square feet. And then here's just a little graphics of some of the building programs and how commercial buildings have grown over the years and along with population size. And now we're going to talk about the economics of mass timber.
So mass timber can save you on construction projects. Comparing the construction schedule to that of traditional materials like steel and concrete, we noticed that it requires less foundation work and finishes, thus reducing the construction time by 25% and cutting the cost. Moreover, it has a higher R value than both steel and concrete, requiring less insulation and reducing the overall heating and cooling cost. Now moving on to the sustainability of mass timber. So trees naturally absorb CO2 as they grow. These raw materials are harvested from sustainable forests. During the production phase, the byproducts are processed into pulp and bioenergy. At the end of the life cycle, the building can be dismantled or recycled, which reduce the waste and extend the material's sustainability. Mass timber's low embodied carbon makes it more sustainable than both steel and concrete. Timber operates in a closed carbon cycle where trees absorb CO2 and the CO2 is stored after construction. Meanwhile, steel and concrete has open cycle, releasing CO2 during production without natural absorption. Here is a comparison of the global warming potential of different building systems. We noticed that reference design 1 and 2 made of steel and concrete have higher emission compared to building 7 made mostly of mass timber. Even though mass timber is sustainable, harvesting them can lead to deforestation due to the inability of the planet to meet the growing demand. Moreover, Moreover, a tree can store much carbon than a mass timber building. A research showed that the carbon is stored in the soil of the tree. Thus, harvesting can lead to a lot of carbon emission. Now moving to the mass timber delivery.
So the two types of delivery, as I'm sure most of us know by now, are flatbed trucking and freight rail. Now each one of these comes with its benefits. However, freight rail is much more environmentally responsible choice, is the much more environmentally responsible choice. But it is not the solution for every project, so these are just some of the questions you need to ask yourself during the beginning phases of the delivery process. Now looking at some of the health and wellness factors related to mass timber.
So mass timber is a safer option to work with. Construction workers face the exposure to hazardous particles, which include silica found in concrete and lead found in steel. Long exposure to them can lead to lung cancer and organ dysfunction. Moreover, mass timber has better indoor air quality than concrete and steel due to the ability to avoid VOCs and the adhesives, which are harmful chemicals when inhaled. Now for the occupant experience, not only does wood offer functional benefits, but also enhances the aesthetics of a building. A survey was conducted to see how people perceive different materials. Wood scored the highest in terms of visual appearance. While mass timber has many benefits, one of its drawbacks is its acoustic performance. The STC and IIC are two important measurements of sound isolation. For commercial building, the recommended values range from 50 to 65. However, a bare CLT has an STC of 40 and an IIC of 25. Thus, we need to take certain strategies to enhance the sound in a building, which include using decouplers, using noise barriers, adding mass, and treating flanking. Now for the material consideration.
So our primary manufacturer was StructureCraft, so I looked at a couple StructureCraft buildings. This is the event center at Metropolitan Park, which uses CLT and glulam in this tall office building. And as you can see, the materials are left exposed. This is another StructureCraft building. This is 44 Commons. It is a medium-sized office building, and it uses DLT and glulam, where the beams and ceilings are left exposed in the working spaces of the office building. And this is the Houston Endowment Center. It is a hybrid structure using CLT, glulam, and steel girders, leaving all the materials exposed within the circulation spaces, as you see. So now we're going to go over some precedent studies, starting off with the Aquatic and Community Center in New Westminster, British Columbia. It was completed in 2024. This building uses folded plates, which effectively distribute loads and allows minimum columns and large spans. Here is the structural system. Here is the floor plan. And as you can see, since there is a lot of large pools, there is no typical bay size, but it was kind of estimated about 27 feet on center. This building in New Westminster was the first to achieve zero carbon building design standard, and the sawtooth roof allows for the pools to be passively ventilated. This is the Sarah Campbell Blaffer Foundation for Conservation in Houston, Texas. It was completed in 2021. This building uses dowel laminated timber, glulam beams, and glulam columns. Here is the diagram. And then next you will see the floor plan. The floor plan is laid out on 18 feet on center. The structural, 10,660 square feet of the DLT roof panels were shipped and installed in 4 days. And as you can see, the mech support is housed below the main floor with 14,800 square feet, and the ceilings were then able to be 22 feet tall. And all the necessary equipment was left exposed and kind of as an interior design decision for the equipment that was needed in these design spaces.
So here we have my first precedent, which is a sporting arena in Moscow, Idaho. So with this project, they use a combination of glulam systems with steel, and the variety of systems created some very unique bay arrangements. And this project focused on two main things, with the first being MEP integration. So they actually prefabricated the portal frame with the duct already inside the channel between the cords, and then they lifted it into place. And the second focus was sustainability. And with this, they sourced 80% of the wood from forest lands that the University of Idaho already owned. And then my second precedent is an ice rink located in Quebec. So with this project, they also used a combination of glue lamp systems as well as some hybrid elements with steel. And because of the angled V columns, there are actually two different bay sizes at the roof and the grade. And similarly, this project also focused on MEP integration, and you can see here how the electrical conduit is actually incorporated into the column itself. And although the project benefits from the sequestration of carbon, they source their products from Haaslocker 4,000 miles away instead of choosing one of the more local Canadian companies only a few hundred miles away.
So for my first precedent, it is the arena stage at the Mead Center located in Washington, D.C. in 2010. Its structure is made of 18 parallel strand lumber which holds the steel truss, and its grid system is circular to allow a flexible, wider design. For the electrical wiring of the building, it is hidden behind the ceiling panel. For my second precedent, I have the Cathedral of Christ the Light in Oakland, California, built in 2008. Its structure is made of 52 Douglas fir column timber columns, joined by 724 louvers. The columns are situated to allow the hierarchy at the center of the church. Moreover, the church barely uses any lighting. Its fritted glass facade diffuses sunlight inside the building. Now for the conclusion.
So just in conclusion, mass timber is an efficient building material and a sustainable choice. There are so many opportunities with mass timber, so going forward, we like to experiment and create new and efficient mass timber designs, and we're looking forward to getting into the next part of our studio. Thank you.
Alexis is joining us. She has her undergraduate degree from the University of Michigan in architecture and her graduate degree from Harvard, both of which were with distinction. She's currently, a native of Detroit. A native of Detroit and now visiting and seeing the differences since she's been gone. She's currently an associate at Wechter Architecture in Portland, where she led the design and construction of the Mississippi Workshop, which is what she's here to talk about today. It's an innovative CLT building that pushes the boundaries of seismic design and fire engineering. Before joining WA, she worked at multiple firms, including Ply Architecture, in Ann Arbor, Marble Fairbanks, A+I, and Frederick Tang Architecture in New York City. In addition to her primary role as project lead at WA, Alexis holds a deep interest in architectural education and historic analysis. She co-taught a studio at the University of Oregon titled The All Wood Building. And she's a registered architect in the state of New York. So thank you for joining us.
Thanks, Ralph.
Now is it on? Okay. All right, so as Carl mentioned, I'm kind of representing the other. So obviously there's a lot of focus on Michigan, which is fantastic, Detroit, but also the Great Lakes region. I do want to mention that although we're in Portland, I am working on a missing middle housing project in the Woodbridge neighborhood with a very small young developer, XYZ Development. But hopefully the next few years, you'll see it's at Forest and Grand River. You'll start to see a lot of development around there where Woodbridge kind of like peters out towards the west. So hopefully good things are coming to that part of the city as well. So this is just before I dive into this building, which is, we call it the workshop. It's where our office is located. We were the self-developers of it. We also acted as the GC. I won't go into what that experience was in depth, but it was incredibly hard, and I have a lot of respect for construction managers. It's located in, I don't know who's familiar with Portland. Has anyone been there before? A few folks. So Portland is divided into quadrants. There's a city that separates the west from the east side, and then there's north and south. This is located in the inner northeast neighborhood, the Mississippi neighborhood. It's on Mississippi Avenue, therefore it's the Mississippi building. We didn't get very creative with it. Something to note is that it's on a commercial street, which is Mississippi, which you see there, but directly behind is single family residential housing. So that comes into play when we talk about the massing, the window, the fenestration, the siding, etc. So something we like to talk about a lot when we present this building is why create an all mass timber building. It was really experiential simplicity. We're talking a lot about sustainability. We're talking a lot about where materials came from. But as architects, we wanted to come to it from like, what's the most minimalist expression of structure and architectural finish that you can get into a comprehensive whole that's experiential and understandable for anyone walking into the space. You don't need to be an architect to understand what the building is and what makes it special. It was actually going to be all concrete for a while until we realized that was wildly expensive. This is a self-funded building through a bank loan for small businesses. And then this is also when it started being dreamed about in the mid 2010s. This is also when mass timber, as we've seen from it, started to really blow up in Portland and in the Pacific Northwest. I'm going to go over this stuff pretty quickly. Usually when I talk about this building, it's an hour and a half. So I'm going to really try to go through. So this is a physical structural model of the building. So you can kind of see through here. We'll talk about more. We haven't really talked about construction techniques. We've talked about like mass timber and primary systems, but we haven't talked about like platform framing versus tilt up. So this is, you can see in the structural model, it's a tilt-up building, meaning the walls, the shear walls go all the way from the base to the top, and they're tilted up. You see this a lot in like some kind of, sometimes concrete. You do see it, I will say like for mass timber, it's not great when you need acoustic isolation between the floors. You get a lot of flanking as the wood checks. And then no matter how much you seal between the floors, the sound will get into those checks and come right up. So that's something to think about for residential, certainly, and other programs where you really need acoustic isolation, but it does erect very quickly. A picture of it during construction, a picture finished. This is our meeting room. Context, I'll go over this very quickly. Once again, it's in northeastern Portland. A look at the building stock. Something else that we don't really do at Wechter at all is curtain walls. We really kind of lean into the facade, the punched opening, both for financial reasons, budgetary reasons, but also the context and also the kind of human scale. For us, the punch window is something that gives a sense of character to the building and the way we perceive architecture a little bit more so than like full glazing does. It's also much more environmentally friendly when we talk about sustainability. Glazing is like the #1 energy killer of buildings. A look at the building in the foreground, looking downtown towards Portland. Okay, so how do all the elements fit together? So there's a few categories I'll be focusing on. The programming concept I'll go through a little bit more quickly. Material systems, construction sequencing, waterproofing and insulation. This is also one I think is going to be really helpful for the students. Systems integration, which was I'm not going to call it a nightmare, but it was verging on a nightmare. And then I'll show some construction details, and then we'll get into codes and fire resistance because we had some interesting conversations with the city for that one. Organizationally, also talking about sustainability. It's not just where the products come from and the carbon footprint, but it's the use of the building and how useful it is for people and the longevity. I think a student group yesterday said something about how people respect spaces that are special to them, that have character, and they won't want to tear it down. And that's exactly how we think about sustainability. Sustainability is kind of like a given, or should be a given for most projects now. It shouldn't be, you shouldn't get a gold star in my like feeling for making a sustainable building. That should be the base level. So how are other ways we can think about sustainability, future-proofing a building? So this is a cross-section, kind of a diagrammatical cross-section through the building. looking at all the different uses of the spaces. So it's a mixed-use building. Currently, it's residential on the top floor, our office is on the second floor, and there's commercial on the bottom floor. But in the future, it could be residential on the middle floor, commercial on the top floor, et cetera. And we'll talk about how we future-proofed a mass timber building and all the systems that go into it to be useful if the needs should change in the future. Looking at the first floor, it's what we call like a European courtyard style building. My boss worked for Renzo Piano in Italy for 3 years. And even though that was like 20 years ago, it's still very much everything is European. So you enter the building actually not off the street. It's a very like narrow, like Portland has very narrow sidewalks. So actually you enter through the courtyard and then there's a few different spaces you can go into. Currently there's a coffee shop on the bottom floor that has primary use of this courtyard. On the right of your image of the screen here is what we call our workshop. We rent it out to other creative folks in the neighborhood. We also use it for our own exhibitions and in the future model making. And in the center is really the spine of the building where we have the bathrooms, where we have the vertical circulation, and that's how you get up to the offices and the residences on the second and third floors. Looking at it from the street, you can really see those punch windows and how they start to speak the language of the apartment building next door. Going in through the courtyard, and then different uses of the courtyard and the flanking spaces on the left. The courtyard during the summertime. It's amazing how cooler the space is in here because it kind of creates a natural stack effect when you go in. So also thinking about that and how your building is formed, especially in an urban environment where you have a lot of concrete islands. The coffee shop, our event space. Second floor, same layout. We really wanted these 3 floors more or less to be replicable for, once again, that flexibility of future use. Here's the stair. We'll get into this glue laminate CLT stair, the connecting hallway. This is looking, once again, at our meeting space area. This is the work side, the computer side. We have about 10 employees right now, so we all work in one room. Those 2 spaces can look across at each other. The third floor, where my boss lives. So in the morning, you can sometimes he's looking down at you through the courtyard. Hi. He also is kind of like Rear Window. If you ever seen it, he really likes just standing and watching people in the courtyard because it's like his building. It's a unique environment to work in. So the living space, once again, looks exactly like the working space below, furnished differently, obviously. He has 2 adorable cats that will never make into the office because they chew cords. Okay, material systems. So you've all been researching CLT. I don't want to get deeply into this. We did go with KLH in Austria. The reason being we sourced this building was permitted in 2017. So when we're all talking about how Michigan hasn't adopted the 2021 code, this was the 2014 IBC code because it went into permitting in 2017. Oregon had not yet adopted the 2017 code. So this building was done in a code that was more restrictive, or at least very similar to what the MBC is right now. So just to keep that in mind. We went with KLH because there was a huge run at all the manufacturers and the mills in Oregon and in BC. You could not source wood. It was expensive. The lead times were long. And then the milling capabilities at that time were a little bit less advanced than they are now. There are certain things like that stair that you saw earlier that people did not want to provide. They were like, we'll give you the wood, just get a carpenter. And we're like, this is, these are like 400-pound panels. A carpenter is not gonna sit there and make this huge heavy stair out of it. So KLH was just entering the North American market at this time. They're huge. They had the ability, a little bit of economics here, they had the ability to undersell their product to get a foothold in the North American market, and we benefited from that. Talking about sustainability, some of you yesterday heard me talking with Pat about maybe it's a misconception in the Pacific Northwest that it's really hard to get certified sustainable fiber. So this is a chart that we look at quite a lot. This, I think it's called Carbon is King, is the name of this book. It's a bit older now, but it's still quite good. But thinking about, we talk a lot about transportation, but really what's the most important thing is forestry. So this line, so this is carbon positive, carbon negative. Transportation-wise, we're this dashed green line. So very good sustainable forestry, and then longer distance transport. So we're going up a little bit higher than if it was closer. But our understanding at the time was we would have been more up here with the choices we had in 2018, 2019. Pat might argue that, but that was my understanding. And just, so this is the EPD that we've been hearing about. So the building grew back in Austria in their forest in 15 minutes. And the way it was received in Portland from Austria was by freight, then by boat. They went through the Panama Canal. Portland is a port town. It came up, it sat in the port because we are like a landlocked urban site. We have 0 lot lines on all sides. And then it's a bus. Mississippi is a public transportation line, so we really didn't want to shut that down. So every day from the port, we got a shipment of the panels that would be used for that day and the next. So here is the shop drawing model. So Michaela is probably familiar with this part of the process, but I modeled the building in Revit. Our mechanical engineer did not use Revit. He only used AutoCAD, so I modeled all the ductwork myself. I modeled all the sprinklers to get all the penetrations. And then what you do is you send your Revit model, in this case, to KLH. They run it through their milling software, their optimization software. They send it back as, in this case, a SketchUp model. We go back and forth. That's how the process worked. In the end, we do get a true two-dimensional shop drawing set. What was interesting for me, this is my first CLT building, and this is truly almost all CLT, is the shop drawing was it's essentially the entire building. Usually a shop drawing is, maybe your millwork or like the windows or some kind of special detailing. But in our case, it was truly the entire building was like the shop drawing. So as soon as I was approved, that was like the most stressful part of the shop drawing phase of CA was the building, and then everything after that was pretty much rote as far as my experience. Just some pictures of the KLH factory. These are glue lambines. We'll talk a little, some students have talked about the connections. I think Nate did as well. We just colloquially refer to this as a Rikon connection because Rikon is the manufacturer. But we'll go into like how a tilt-up building gets sequenced, and this is a very important connection for that. These are our panels being loaded onto a truck. All of our panels, most of our panels fit into a typical truck bed. We did have one shipment of oversized because it's a tilt-up, and we have a mechanical penthouse on top, and we needed slightly higher panels for that portion. Okay, so this is a quick animation, but I'll flip through it like a sideshow. So if you recall the site, it was right up against that apartment building, right? So that's a 0 lot line. You can't get to the exterior for your insulation, for your waterproofing, for your siding. So the first 2 walls of the U had to be constructed on these giant sawhorses face down in field. And then they were lifted up by this mobile crane that did park on the transportation street for a little bit. Then that mobile crane was used to build a little tower crane. And then the mobile crane went away to Seattle, where it lives. And then that mobile crane on site erected the building. The way the building was erected is first these tall, thin tilt-up panels were lifted up and secured to the foundation. Well, I'll go through some photographs of how the structure and the detailing works. And then because remember we have punch windows, but this is a tilt-up building, so these are then stitched together, these tall structural members, which even though when you're experiencing the building, it feels like a wall, these are technically columns. They're super tall, thin columns. And if you remember anything about your slenderness ratio in structures, they need to be stiffened. So the floor plates and the glue lams in this building essentially stiffen the building. The entire thing forms a rigid structure because remember Portland's a seismic zone. So this puts a lot of pressure on the connections. There is a huge amount of steel in this building. You don't see it, a lot of it, because a lot of it's on the exterior, which is then hidden underneath the cladding. But so first we have what we call these tall, thin columns going up. Then we have the spandrel pieces, which are the pieces in kind of like above and below the windows. And those are a piece that helps tie those tall, thin columns together. And they have these half-lap connections that you'll see in some photographs later. So we're doing one wing, and then we're going to move to the other. And the reason we're doing that is to start kind of sequencing all of the subs that come in afterwards. So first we're putting up the CLT on the wing of the building that's on the street. The way that works after the spandrels are put in is the beams are dropped into the top, then the floors on the beams, et cetera, et cetera. So I'll some construction photos of that as well. Now the middle portion and the other wing start, while that CLT is being erected, we now have our electricians and our roofers starting to work on the one wing. So hypothetically, in an ideal world, the building will like kind of finish very quickly because the CLT goes up fast, and then you kind of have this rolling cascade of subcontractors working on their trades. Middle core goes up in the same fashion. First the walls, then the beams, drop down, then the floors. Our penthouse, then the back. We do have some steel here. You'll see these big moment frames down there. That's because we have these garage openings off the back alley, and because of the way that the CLT is vertical, it cannot span those openings. If we had done them out of glue lams, we did think about doing glue lams. The glue lams would have been like 5 feet deep and actually come up into the next floor, so we would have seen them from inside. So we decided to go with steel. So some actual photographs. These are the footings being formed. And we see these tilt-up panels. The skin of the building is a rain screen cladding that's a weathering steel. But we didn't want to use, even though it's not very expensive, the black corrugated siding is cheaper, and it's going to be hidden by the adjacent building. So that's why it's black there. Those are lifted up, and then we started construction on the perimeter wall. You can see we did kind of like a mock-up of the weatherproofing right there. That's the orange. We're still kind of like it was our first CLT building, and as I mentioned, we acted as a general contractor. So it's like zero knowledge of both of those things for us. Never had been a GC before, never done CLT before. I had just arrived from New York. I had never worked on a ground up building before. I had never permitted anything in Portland before. It was like during the pandemic, there was like a lot of stuff going on. The CLT erector had never done CLT before. They were like a young erection team from Washington. It was a lot of firsts. It's actually kind of amazing the building got built. There was a lot of times we thought it wasn't going to work. And then we put down a temporary roofing. It was Portland in the winter. The roofing failed, so we had to put up, we put down a peel and stick temporary roof, so then we had to build like this protective roof and take the roof off. It's another thing is we did not, it was supposed to be a dry Portland winter, and ended up being the wettest winter on record. And this was erected during the winter. It got hit with rain all the time. So now you can see the new roof going up, that middle section. The second wing on the alley. So then we'll talk about waterproofing. So this was something I don't think I've shown to students before. We always get these questions from students and architects. It's like, how did the windows go and how did the waterproofing go in? So like I said, it's a tilt-up panel. We used a self-adhering membrane, and this is a breathable membrane. That's very, very important. You don't want to choke the CLT. You want to let it breathe. Wood breathes naturally. You don't want moisture to get stuck in the wood and then potentially rot. And like I was saying, this thing was getting pelted by rain all the time. We've actually had the roof fail 3 times since being in it. And every single time, the building breathes. It breathes out. So this is a vapor permeable membrane. It's just stuck onto the building. Our openings were then had a secondary membrane put in them, and then the way we flashed out the windows is we actually, the trim went into the opening and became the flashing, and the window actually just sits in there on clips. So it doesn't have nail fins. It's not nailed to the substrate like most windows in North America are. They're actually on clips and then set in. It's a slightly more expensive detail, but even the sheet metal guys were like, this is like a fireproof detail or a water, you know what I mean? It's not going to fail because then this sheet metal becomes the back dam. And so there's really no way for the water to get in there. Then we had about 4 inches of mineral wool on these Z-girts. So once again, mineral wool, it dries. So if it gets wet, it can dry out. And then we clad it with this rain screen. It's weathering seal. You can get pre-weathered, which Corten I think is, you know, what's referred to usually. We chose to go with non-pre-weathered. It was cheaper. It also weathered very fast. It was really cool to see the building change and the neighborhood react to that. A lot of people were scared it was going to be like shiny forever. Systems integration. So I'll try to speed up a little bit. So we have, it's all mass. So you have to think about where the vertical and the horizontal spreads go. So vertically, we have 3 cores that you see here. And then we have heat pumps on the roof of the penthouse. So on the left, our primary heating and cooling is hydronics in the slab. We have a secondary air supply that's also fed from the same hydronic tanks. And then power and data is also spread horizontally through a non-structural topping slab. The roof. This is all the hydronic, it's a hydronic manifold. We had 4 inches of non-structural topping and it barely covered all this stuff. On the right, you can see we're feeding our lights from the floor above. That's what they do to get through the thickness of the floor. They just like turtle all of these game plates together. It's kind of wild. So here's with the acoustic mat on the bottom, the radiant, the data, the power, and then that's it when it's covered up. So all of our power comes up to the floor, all the lighting comes down from the floor above. We do have some plumbing penetration to think about, but largely it was like the horizontal spread through that topping slab was our strategy. The downfall of that, obviously, as the students are probably seeing as they study these different methods, is that if you want to change anything, you have to rip up that topping slab, and you can't do that easily because there's hydronics everywhere. So you can't just, even if you want to fix like a piece of millwork or something, you really can't do that. That's the one big downfall. Okay, so we talked, I think someone yesterday, maybe it was Michaela, mentioned like these huge tall panels like in the wind. So that's, you know, like a 40-foot high by like 6-foot wide panel and in the wind. And these guys have to set it down on what you don't see here, these little like blockouts in the bottom to keep it from slipping in case of like a seismic event. So they have to get this thing up and like situate it perfectly. It was amazing what they did. It sits on this cushion, this rubber mat at the base that's for water and termites, but it's also to keep the fibers from crushing themselves. So the GC guy in our office tried to VE it, and our structural engineer was like, no, that's a structural detail, because the fibers, once again, these are very tall, will fracture themselves if you don't have that cushion at the bottom. So the way that the walls are held to the foundation, remember, once again, this is a seismic zone. The whole thing is rigid, but it wants to turn over in case of a seismic event. So it's really got to be stiffly and firmly like rooted to the foundation. Is we have the steel angle going all the way around. So the CLT itself is not directly connected to the foundation. It sits on there. It's attached to the steel angle, which then itself is attached down through embeds into the foundation. And we originally wanted to hide it behind the skin of the building, but with the 0 lot line, we decided in the end to celebrate it with these huge metal connection details that you can see from the inside of the building. talking about dropping down the beams. This is after the walls are up, they drop down the beams. This is what we call the Rikon connection, slip connection. And then you can see, obviously, I've been at like the IMTC, they're like, don't ever let water get on your slab. As soon as it gets on your slab, like broom it off. And they're like, or you could have major failure. And I'm in the back of the room being like, oh my God. But it's okay, it lasted. So you can see them bringing down the panels. Here's a shop drawing of our stair. This is the stair in erection, kind of coming in. They went in from the core from above. Okay, I'm really trying to race through this. There's so much to talk about. But okay, codes and fire resistance. We talked about char. We don't need to talk about that again. So this was type 5B construction. I mean, it's not a tall building. There was no type 4 at the time. But even though it's type 5, because it's zero lot, because we had multiple occupancies, because we had an egress stair, because you're exiting and then re-entering the building at that exterior passageway, there's so many moments that had to be 1 hour fire rated, luckily not 2 hour. And we got in trouble with the inspector during construction because we were down against the line trying to get it permitted. We had one last chance to get it permitted. The plans examiner wanted to see fire caulking called out in the details per IBC like you would for JIP. And my boss was just like, draw it. And I was like, okay. And then we didn't install it, and the inspector caught us after the building was erected. So we were, kind of sweating bullets. One thing we tried to do is add fire caulking after the fact. It does not like to attach to wood. It went all the way down the building, as you can see in that picture with this red stain. So we were like, shoot, okay, what are we gonna do? So we engaged a fire engineer in Portland who looked at the connections, who looked at obviously is knowledgeable of the code, and who looked at the way wood works. And it's not even that wood forms a char layer naturally, it's that intumescent materials were actually developed to mimic what wood does naturally. So what the char layer is doing is it's protecting is because it's depriving the fire of oxygen and of fuel. So his findings after going through all of this, and you can actually find this if you're curious, like in Portland, you can look up any code appeal and the language is all there and you can read. And I think this is the most important thing for other practitioners, is that they found that the connections are so tight just because of the way the building is needing to act structurally that there's no way the fire could get in between any of the T connections, in between any spline connections. And furthermore, his finding was that intumescent materials actually hurt wood's natural capabilities to defend against fire. So I'm really hoping that, I don't know who needs to see this, but that eventually gets into the IBC, because even the American Wood Council's book shows caulking in their details. Lastly, we did get a Wood Innovations grant for this project for post-occupancy study, which is incredibly unusual. There's going to be findings released to the public. It's both University of Oregon has been doing analysis of like environment, CO2, blow tests, etc. And we're also looking at potential ways of different kind of like structural, mechanical, and material systems for different kinds of building types, and how to kind of have a kit of parts and really engage builders and developers in Portland, but outside of, to kind of gain an understanding and price these things out so they understand that it's not necessarily more expensive than a hybrid or even a stick frame building. So that's kind of the next steps for us. These are the diagrams that were in the previous group's presentation, but also really looking at systems integration, because that's probably one of the most challenging things for if it's a true mass timber building with no voids. Thank you. Sorry.
You're not going.
Oh, we have to come up there.
Have to.
We must.
Let's.
All right, we'll have some time for questions. I think this was this was kind of my goal. And maybe this was the ideal panel because we have big ideas. We have ideas from a kind of development perspective, and then also really nice to include Alexis, where I think there's the perspective of like design, build, and occupancy all in one, for better or worse for you. Sounds like an amazing experience. And I think one of the issues that I raised yesterday in support of our students is just maybe this aspect around mass timber, in that so much of what we need to discuss is almost beyond the scope of architecture, right? And I think, Sandra, you brought this up, things that contractors need to know if this is going to be applicable. I think from Jake's perspective, things, that math, the mix, the equation, how do architects start to think about plugging into this as they get their sites, and then the perspective from Alexis. And so I think we can open this up to questions, but I think maybe the first topic related to this is just those things beyond maybe what we encounter in an architecture studio, what you might suggest for the students to be thinking about. I think each of you raised and brought these questions already, and so maybe I'll hand this over.
I like to use the microphone. It's better. So I think as architecture students, it's really important to, and remember, I'm not an architect, so I'm like this rando telling you what to do. But I think it's really important to be thinking of, rando. I think it's really important to be thinking about the fact that on a mass timber project, you have to expect a longer pre-construction timeline, and you have to be collaborating early and often with all of the project partners in really deep ways to advance the project effectively. And it might not be the way that you might normally work. And I think that's very exciting. And the other thing I think is really critical is to be knowledgeable about some of the barriers that will come up in the process and know how to kind of gently advocate for other members of the project team to, look at resources, to connect with other experts, to really get the answers that they need in order to move forward. It's not up to you as the architect to solve all the problems, but the more knowledgeable you are about the types of barriers that might come up, the more well prepared you're going to kind of be to be able to coach, because you're going between the developer and the construction manager and the supplier. You're doing all of those things. You're the facilitator, and you just have to be equipped with those tools and resources to point people to, I think.
Yeah, my Topo Chico was gone, and that's very sad. It's okay. I'll get another one. Yes, I do, but I can solve that myself. Yeah, this is probably a little agnostic of mass timber, and I'm thinking forward to like in maybe half an hour or so while we're eating lunch, and I'll introduce the sites. It is really a programming challenge, right? I think the gut reaction is always to maximize, from an urbanist standpoint, to maximize density and site usage. But something that I'm always struggling with across our portfolio as we think about going vertical is if we just, right off the gate, just maximize density with, the most amount of residential units or hospitality or office, that it just doesn't really work quite yet in the city, because it's still the Midwest. There's a lot of space. There's not that many people when compared to other markets. So really, engaging a little bit of sort of market research off the top of like, what is the right mix of density, of program, of adjacencies at this time in 2024 or 2025 for optimization of site usage for your project. I think would just doing that for a week before you dive in to design, I think will go a long ways, and there's people that can help with that.
That's super interesting because I ran a mass timber studio at U of O, and they're very program based. And what we did was we actually made them design their buildings without program. We gave them a site, we gave them like floor levels, we gave them a different structural system to choose from. Do they want to do panels? Do they want to do post and beam, shear, etc.? Do they want to do long span? Do they want to do a grid? This is like definitely like not what a developer would advocate for, a programless space. But it worked in Portland because I think it's a mid-scale city. It's denser than Detroit in as much as like there's not as much emptiness, but it's also much smaller. So the kind of that like middle ground site. But what's interesting is the students got to like really go into the structure and right into the details, without worrying about kind of like, at least in Portland, social justice or like kind of like what kind of incubator. But if you have someone who's giving you a program, I think that could be helpful. But really from at least the CLT perspective, it's limiting in a lot of ways. And I think that was freeing for the students, because it has a structural like rigor to it. It has, dimensions to it that you really like the way gravity works with it. There's like not, oh, there's not like, well, there's a lot you can do with it, but it's limited in a really proactive way. And then instead, what's exciting for the students, I think, is you get to start thinking about those details like plumbing and stuff and do it in a cool way. Like really take a stance on that. Like, what are your systems doing? Are they stationary? Are they central? Are they spread out? Are they like exposed? Are we really kind of like trying not to hide stuff anymore, but bring it to the forefront? Like, what does that future look like? And that's a level of detail that I think you're allowed to explore aesthetically with a system like this that you wouldn't be able to if you're just saying my building's made out of white, like it always was in the past.
I think it's funny too. Alexis has been recounting all the things that I did to her as a faculty member, and now you just disclosed that you did that too. We didn't give them programs. Like think forward like 10 years.
Hi, Jake. I have a question for you. Um, I just am curious, as citizens of Detroit, how do we follow along on the journey that you're creating with this like creation of the kind of flow of wood into Detroit and bedrock, and how do we like, is it an Instagram thing? Are you guys like, how do you like disseminate this knowledge?
So this is probably one of the first times that we've actually talked about this outside of just Sandra and I engaging like very specific subject matter experts. Over the next couple months, we'll start to be. Yeah, I think so. I think so. Yeah. Yeah. Over the next couple months, we'll start talking about a bit more. I mean, you're gonna sort of sneak peek this at Climate Week in New York City next week, which is pretty dope. And then we're gonna have a convening, which is sort of invite only by design because it's still very much like half baked in October. And then we're gonna work on like a playbook, which is meant for publication by the end of the year. I'm going to share it with the World Economic Forum in San Francisco after that. So like it's still very much kind of like internal. The idea is by the end of the year we can start being more like outward facing with it. So that's a long-winded way, and I'm nothing if not long-winded by saying like stay tuned, and hopefully Q1 of next year there'll be like some outbound sort of narration on that.
So we're collaborating on the Great Lakes Regional Mass Timber Collaborative, and so that whatever comes out in terms of like an action plan, then we'll be starting to reach out more broadly to engage more and more people in each of the states that are considered to be part of the region. Once we know like these are the elements that we think need to be a part of this, what do you think, and where would you like to plug in? Are you with Rossetti? I saw your bag. I was like. I mean, we have a robust community of artists that I have mailing lists.
Yeah, no, for sure. And we may or may not be working with Rossetti on some East Riverfront projects, right? So like, yeah, everyone's yeah, plugged into the ecosystem in some capacity. I think for the Great Lakes Consortium and for Bedrock's involvement in the supply chain, it's still very much like partially baked. But like Q4 is per the Wood Innovations grant that we have, Q4 is when we really have to start putting that to paper in terms of a plan. Yeah.
She has another one.
But now we have a student question, so you have to wait.
Hi, I had a question towards Alexis. So when you were talking about your construction in Portland, you were talking about like the heaviest rain and like ever during the winter. You kind of talked about how the protection of that process goes. Can you just like go more in depth into that and maybe give some like alternatives to protecting it during the construction process?
This is actually a really interesting question because I asked the same question at the IMTC and we would not have actually been able to tent the building because we had a crane. Like you can't tent over the crane. There are actually some cranes that do have like tenting on them. That's what the guy at the MTC said. What we could have done and what we do see is what's the part of the wood you really don't want to get wet, which really got wet for us, is the end grain. Because that's what soaks up and that's what like it's not going to change much like lengthwise, but it can really like soak up there. So we did have our structural engineer on site like monitoring it and how it was drying out to like make sure nothing was compromised. But the entire top of our parapet was constantly getting soaked in all of our window openings. We're constantly getting soaked. So what I've seen, and I'm sure others can also speak to it, is like protective like membranes over like column tops that haven't been like covered yet. When the slabs get wet, like you saw in some of the images, like brooming off that standing water as soon as possible. When we did have to dry out our building, when there was a breach, don't dry it out too fast because if you dry out too fast, the wood will crack. So there are a lot of protective measures during construction, but like those all take time. So it's all part of, it's all part of the equation. For us, it took a lot of time because we put on a roof, we had to take it off. We had to cover it with a temporary roof that wasn't like that great. And yeah, it set us back. I will say, like, when you're developing your own building and you're your own client, your own architect, it's stressful, but it's also you're responsible to yourself. So in a great way, I'm really happy that we did not have a client for that building that was paying us for it, and we can use the building as a laboratory and really learn from it. Like we could take chances, which is not not something that a lot of architects get to do. So we were pretty thankful for that, even though it was stressful as hell.
So our, MSU has a construction management program, not architecture. And one of the things that we learned through the construction management program that we now teach people was that when our STEM facility was being built, like with your building, which was not all done by ourselves, but we had an architect, an engineer, construction manager, and an installer, none of whom had ever done a mass timber project before. And so they did a great job of learning together and figuring things out on the job. But that question of, oh no, what if it gets wet, did come up, and it did get wet, and they swept it off. But one of the lessons learned there, and as designers, this is one of those things, even though this isn't your responsibility, that it might be helpful for you to know so you can advocate for, is make sure that your construction manager writes into some subcontractor's scope of work that you have to be prepared to clean that off. Like otherwise, everybody will be like, "Well, I don't know who's supposed to get it in there so that it's somebody's responsibility."
They were talking about they had like a huge shop vac. Yeah, just vacuum up that water and just dump it out every day.
So I'm thinking about the lot line, the zero lot line, and fire code. So could you like maybe talk about, was there a difference in thickness of the wood, or was it all kind of fire rated, or?
I don't know who that is.
Oh no.
I'm also culturally like not. I'm like from the 19th century, I think. That's also a good question. So what I failed to mention in the like push to get through like everything about the building in 30 minutes, which I don't even know if I did, is that it is 5-ply. Like everything, well, it's shear, everything's lateral, everything's shear, everything's gravity. There's like 2 partitions that are not structural in the entire building. So in some places, we did need 5-ply for structural, but mostly it is for the char. It's for that 1 hour char. The only place where there's CLT3 in the building is the roof. And then because of that, and Michaela's like, yeah, because of that, like my boss had forgotten about that and he wants to put trees up there. And our structural engineer was like, nope, no potted plants. And we're like, okay. No potted plants. But even something I failed to mention also when I was zipping through everything, that the glulam beams are really oversized between the 2nd and the 3rd floor because that's between the B occupancy and the R occupancy. It's all in millimeters because of KLH, but they only need to be 180 and they're 240 millimeters. And that's once again for the fire protection.
Okay, so someone brought this up earlier and I forgot who it was, but they said something about how mass timber can be really attractive for developers in bringing higher rent prices. So I guess how would you balance that, and like what kind of solution would you suggest for the need for like affordable housing, especially in Detroit, and just how like mass timber could benefit with affordable housing just with like the shorter timeline, but it also could draw in like more luxury clients for those just developments.
Who wants it first?
That's a great question. So with commanding higher rent, I always caveat that by saying commanding higher rent like where desired, right? And partially that is to offset any premium that may or may not exist with indexing on a timber product that happens in this market because we're not quite there at scale. With affordable, so 25% of what my company do is affordable. That is almost entirely subsidized by government entities. There's a local program that helps with that. There's state and there's federal, right? So that's actually kind of a wash, especially if it is a mixed income property, right? So for example, if I'm doing a timber product on the riverfront and 25% of that is affordable, it's going to be all integrated within that property, and that 25% that's affordable is going to be subsidized by a government entity, and that is not going to impact the higher rent that I'm commanding for, it's not going to be impacted by the higher rent that I'm commanding for the remaining 75%, right? Now, this is not going to solve sort of a larger issue of a missing middle sort of 130% area media income workforce housing a challenge. It's a much larger question, a much larger answer, but it can sort of, deeply affordable and slightly higher rental rates can sort of exist hand in hand in a mixed income property.
And speaking of, affordable housing being subsidized by government programs, right? If those government programs, because those same governments have sustainability and climate goals and climate action plans, then can start preferring mass timber when they're subsidizing for affordable housing, that can also be very helpful as we're in this space where we're trying to mainstream these materials.
Only that I think you guys are ahead of us in Oregon, which is crazy because we get lost. We're working on a lot of affordable housing at state and federal, and the developer doesn't want to touch CLT. There's no benefit to them. It's more expensive, and the firm that they always work with for the GC, they don't have specialized in it, so they're not going to use it. We definitely need more like state incentives, kind of like the Ann Arbor School District, which is crazy, saying like we need to use this because the reality, at least in Oregon, is that developers aren't going to use it unless like someone tells them they have to, or if there's like a clear benefit that outstrips like them needing to educate their entire like chain of subconsultants and contractors.
Yeah, it's super interesting. In the Detroit market, affordable housing, the affordability of housing, especially on multifamily, hasn't really been deeply impacted by the construction methodology, at least in our experience, whether it's adaptive reuse, historic preservation, whether it's mid-rise condos, or whether it's the timber type of product that we're looking at, because the government incentives is kind of agnostic to the construction methodology, with the exception of, say, like the Hudson's project, which is, the tallest building in Michigan that's going behind you. That's kind of its own thing, and our strategy there is basically say, all right, we're not going to do any affordable housing there, but what we'll do is we'll offset that lack of 25% there with another 25% on another project. So another project then becomes 50% or 35% here and 35% there, in order to have a portfolio-wide sort of aggregative 25%. But beyond that sort of weird outlier, like the money coming in from LIHTC and others is somewhat agnostic of the actual like methodology of which you build it, which is pretty cool. Again, I think the larger challenge that I come back to with affordable housing, and this is not an affordable housing forum, is sort of that like, housing for most people in this room, myself included, to like live in a like Detroit type of market, right? Those making like, working class income at, say, again, like 130 to 140% area median income. That's a big challenge, because there really are not a lot of government incentive programs to support that. There are government incentive programs to support those that are making anywhere between 30% area median income and 80% or 60% area median income. Yeah.
So one of the questions that I have, and it sounds to be like a topic that's being repeated, but like not really mentioned for a long time, is the reusability of this stuff, mass product like products, like the glue, for example, or like what could be done at the end of life. So my question mostly goes to you as far as like, what is the developer involvement as far as like researching or looking for the end of life cycle of mass timber? If that makes sense.
I'll start by talking about some of the key questions that are maybe necessary to interrogate in order to get to a reality in which we have the ability to move mass timber materials that are going into buildings today into mass timber buildings of the future, say. So Jake and I both participated in a workshop in Finland two years ago now that was asking this question. So there were people from Finland and a couple of other US states and Michigan together trying to think about, well, if we're going to do that, what do we need to do to make that possible? And we identified three key areas. There will be more areas, of course, that need to be interrogated, but the three key areas we interrogated were: one, how do we even keep track of the materials that are going into buildings right now so that we can know when they might be ready to be used in other buildings in the future? So what kind of wacky database do we need to be creating, and how are we feeding into that, and how are we getting that data? So it's like a super complicated data problem. That's one thing. The second thing, which I mentioned earlier, was mass timber materials are customized kits of parts. They're super, like they're forgive me for using this buzzword, bespoke right now, bespoke AF right now. And how can we customize, or how can we start thinking about how to standardize elements, which elements need to be standardized and in what ways, in order to make it easier to deconstruct the buildings in the future and then move those materials into new buildings. And then the fourth question was one that Jake actually worded for us in this workshop, and I'm going to try to say it in a way that makes sense to my brain better, but it has to do with because what we want to do, the reason we want to do this is to extend the carbon benefits of trees by capturing this wood and moving it into buildings in the future. How are we valuing the carbon that's stored in those trees today, and what is the future value of the carbon, and how can we be thinking about that and then using those values to create policies that allow us to then do that thing, to extend those carbon benefits, and for that to have a value that's an incentive for Jake today to want to make sure that the wood, the mass timber he's putting in a building in Detroit today, can be used in the future. Did I say that right?
I think so. I vaguely remember coming up with that. It was this idea. Exactly. So of like what is how can I leverage the future value of the carbon that I'm sequestering now in order to capitalize the project today? Almost like a tax increment financing sort of tool. I don't know if that has legs. It was in Finland. There was a lot of gin there. But I'm not gonna. Yeah, I can't find it in the States. Maybe Michaela can help. Maybe. Um, I'll kind of not answer your question because, having done a lot of adaptive reuse historic preservation type of stuff like this, I actually think that the larger life cycle question of materials is less in structure and more in TI build outs and fit outs, right? Like that's the actual turnover. Like this building's been here for 80 years. All of our buildings and most of our buildings in our portfolio have been here for between 160 to 100 years. I think if a timber project is done right, it should sit there for 100 years. But the tenant turnovers are going to be between 8 and 12 years, right? And when a tenant turnover comes in, they gut everything. They get rid of all the drywall, all of the furniture, all the partitions, all of the, the kitchens, the HVAC. That all goes in a landfill, and then it comes in again, right? And that happens like literally sometimes 5-year life cycle. Restaurants are even less than that sometimes, right? Like that's the actual like problem when we think of life cycle materials is that like less than sexy but very real TI build outs. And that's what we need to be thinking about in terms of embodied carbon neutrality. And this is a thing that I've been on with the World Economic Forum and their Net Zero Carbon Cities initiative is that it's not about like, the stuff that you see when you drive down, Woodward Avenue, Michigan Avenue, whatever. It's the stuff that's inside that ends up in landfills.
Yeah, something I didn't really talk about is the flexibility and like how we achieve that. But that's exactly right. I don't really understand, to be frank, like the idea of like designing a building to be taken apart in 50 years. Like that's still going to take carbon, even if you're reusing stuff. Why don't we design our buildings to stay around for like 500 years and design them in a smart way where they're flexible, so like you have multiple uses, but like being specific about that flexibility, so it's not like anyone can put something anywhere. It's like there's a very like in our building, like for the business, the office to turn into a residence. I remember I mentioned there's hydronics everywhere. You just can't put down like base plates for walls. They're very specific, like embedded metal receivers that you have to use a metal detector to find because the concrete kind of covered them up. But we pre-planned where someone would want a kitchen, where they would want bedrooms, where they might want a TV room, etc. And we anchored that future into the building, so there's kind of like a map of like how to use the building. There's specific places where plumbing is. There's future like venting for like a hood. So in that way, you are kind of controlling the potential waste by saying, no, there's very specific places where you can plug into these because of the way the structure is. And also look at how beautiful the structure is. You're not going to like cover it up with a drop ceiling that's then going to need to be torn out unless you're putting a commercial kitchen or something and needs to be cleanable. But basically, I think like architects can really take a position in this and not be scared of like the overbearing hand idea. It's not you're controlling the future, but you're kind of giving a game plan to people. You're kind of setting out a roadmap. And I personally, as an architect, I think that's like a big responsibility instead of saying, oh, the best thing as an architect is to just like give a blank slate and let people go wild. But that produces waste, right? And I think we need to take a real stance on that and like the future of buildings. And for me, it's not how do we take this building apart in 50 years? It's how can this building stay for 500 years and not have this like crazy turnover? Yeah, TIs are insane. They go up and they'll come down in like 6 months. And like the amount of materials, like when I was working in New York, people would like get marble in from like Italy and shit, like whole lobbies, and then like someone else would buy a building and it would be torn out like 6 months later. It's insane. That's a whole different story.
Well, and maybe it leaves us with a couple of topics that I don't think necessarily have answers today, but I'm going to use bespoke AF going forward as a thing, and there may be a T-shirt soon. But I think even maybe the space that we're in, if I think about, and I've said this for a long time with digital fabrication, that trees start and they're not necessarily straight or flat. Then we do all of this work and we get them, we skin them, even just thinking about the plywood that's here, right? It gets to be very flat as a product. And then the first thing that we do when we get it is we bend it, right? And so we do all of that work. And so what I'm thinking about the bespoke AF comment too is that it's maybe not it's like bespoke somewhere in the kind of upstream or downstream, right? That we take something, say the tree, start with the tree that's bespoke, then we turn it into a building product and we use a whole bunch of energy to do that. And then that becomes standardized. And even Michaela was talking about, that those premium projects where we cut those things off because we want something that's curved, right? And so I think for the students to maybe start to grapple with that idea, and I think Alexis brings it up, Jake has certainly brought it up in terms of how we use the spaces, future proofing them, the value of them, and having a sense of maybe ownership or a sense of value of these projects that we do that aren't torn down or they're not renovated or they can be used in different ways. And I think that's an amazing challenge to leave with the students and leave for the studio. So I want to thank the panelists. I want to thank the other panelists that are in the room, the attendees, the students, and we've got lunch off to the side. And so hopefully these conversations continue over lunch. They continue over the course of the semester and they continue over the course of our careers as we grapple with these issues. So thank you very much for joining us.